What if black holes were portals? This intriguing idea opens up a world of possibilities, blending the realms of science fiction and theoretical physics. Imagine if instead of being destructive forces that devour everything in their vicinity, black holes acted as gateways to other dimensions or distant parts of the universe. Such a concept challenges our understanding of space and time, suggesting that these mysterious cosmic phenomena could connect different points in the universe, or even different universes altogether. The notion of black holes as portals would imply that they have a kind of tunnel that leads to another location, much like the idea of wormholes in theoretical physics. Wormholes are hypothetical passages through space-time that could create shortcuts for long journeys across the universe. If black holes were indeed portals, it would raise questions about what lies on the other side. Would it lead to another galaxy, a different time, or perhaps an entirely different universe with its own set of physical laws? The thought of traveling through a black hole, emerging in a vibrant and unfamiliar cosmos, is a fascinating prospect that has captured the imagination of many. Furthermore, if black holes were portals, what would that mean for the laws of physics as we know them? Current theory suggests that the extreme gravitational pull of a black hole would crush anything that falls into it, but if they served as gateways, might there be conditions or technologies that allow safe passage? Scientists have theorized that the information that enters a black hole might not be lost forever, leading to speculation about the preservation of matter, energy, or consciousness during such a journey. Exploring the implications of black holes as portals also leads to fascinating questions about time travel. If traveling through a black hole could take you to another point in time, it would open up discussions about causality and the potential consequences of altering the past. Would it be possible to witness historic events firsthand, or even interact with them? The paradoxes of time travel, often depicted in literature and film, become even more complex when considering the role of black holes as potential time machines. This scenario also invites us to consider the potential for life beyond our own planet. If black holes connect different parts of the universe, it raises the possibility that intelligent life could exist in realms beyond our current understanding. What if civilizations have developed the technology to traverse these cosmic portals, exploring the multiverse and exchanging knowledge? The implications for our understanding of life in the cosmos would be profound, suggesting that we are part of a much larger tapestry of existence. A black hole is an astronomical object with an extremely strong gravitational pull, so strong that nothing, not even light, can escape from it once it crosses a boundary known as the event horizon. This means that if anything gets too close to a black hole, it will be pulled in and lost forever. The formation of black holes usually occurs when massive stars exhaust their nuclear fuel and undergo a gravitational collapse, compressing their mass into a very small area. This results in a point of infinite density known as a singularity, surrounded by the event horizon. In contrast, a portal, as often depicted in science fiction and fantasy, is a gateway that connects two different places in space or time. While portals may allow for instantaneous travel between distant locations, they do not have the same gravitational properties or physical characteristics as black holes. Portals are more about providing access to alternate dimensions or distant worlds, whereas black holes are natural phenomena that represent the ultimate limits of gravity and the laws of physics as we understand them. In essence, while black holes are real and can be studied through their effects on nearby stars and gas, portals remain a fascinating concept rooted in imagination and storytelling. The mystery surrounding black holes continues to capture the attention of scientists and enthusiasts alike, prompting ongoing research into their nature, formation, and potential connections to the fabric of the universe. Scientists currently perceive black holes as fascinating and complex objects that challenge our understanding of physics and the universe. These regions in space are formed when massive stars collapse under their own gravity, creating a point where the gravitational pull is so strong that nothing, not even light, can escape from them. This characteristic makes black holes invisible to direct observation, leading scientists to study their effects on nearby matter and light, often observing the energy emitted by accreting material as it spirals into the black hole. Recent advancements in technology have allowed for groundbreaking observations, such as the Event Horizon Telescope, capturing the shadow of a black hole in the galaxy M87. This image provided strong evidence for the existence of black holes and confirmed predictions made by Einstein's theory of general relativity, which describes gravity as the curvature of spacetime caused by mass. Scientists now categorize black holes into several types, including stellar black holes, which form from the remnants of massive stars, and supermassive black holes, which reside at the centers of most galaxies and can contain millions or even billions of solar masses. Another intriguing aspect of black holes is the concept of Hawking radiation, proposed by physicist Stephen Hawking, suggesting that black holes may emit radiation due to quantum effects near the event horizon, potentially leading to their gradual evaporation over astronomical timescales. This theory has sparked discussions about the ultimate fate of black holes and their role in the larger cosmic picture. Additionally, the study of black holes raises questions about the nature of spacetime and the underlying structure of the universe itself, leading researchers to explore concepts such as wormholes and the potential for black holes to connect different parts of space and time. As scientists continue to gather data and refine their theories, black holes remain a central topic in astrophysics, pushing the boundaries of what we know about the universe. The mystery surrounding these enigmatic objects fuel curiosity and inspire new generations of astronomers and physicists to explore the cosmos, seeking answers to profound questions about existence, the nature of reality, and the fundamental laws that govern everything we see. Black holes are fascinating cosmic phenomena that come in different types, each with its unique characteristics. The most common type is the stellar black hole, formed when a massive star exhausts its nuclear fuel and collapses under its own gravity. These black holes can be several times the mass of our Sun. Then there are supermassive black holes, found at the centers of galaxies, including our Milky Way. These giants can be millions to billions of times more massive than the Sun, and are thought to have formed from the merging of smaller black holes and the accumulation of gas and stars over billions of years. Next, we have intermediate black holes, which are less common and are believed to exist between the mass ranges of stellar and supermassive black holes. These are still a bit of a mystery, as scientists have yet to find many examples of them. Another intriguing type is the primordial black hole, which might have formed in the early universe, shortly after the Big Bang. These black holes could vary significantly in size, from very small to quite large, depending on the conditions present in the universe at that time. The idea of black holes as portals is a popular topic in science fiction and theoretical physics. Some theories suggest that black holes could be connected to wormholes, which are hypothetical passages through spacetime that could allow for travel between different points in the universe or even to other universes. However, this concept remains purely speculative and is not supported by current observational evidence. Moreover, some scientists have proposed that rotating black holes, known as curved black holes, might have the potential to serve as portals, owing to their unique properties related to rotation and the distortion of spacetime around them. These rotating black holes could theoretically create a path to another region of spacetime, but the conditions required to navigate such a pathway safely remain well beyond our understanding. While these ideas captivate the imagination, it's essential to remember that black holes, in their current recognized forms, do not act as portals in any practical sense. The extreme gravitational pull of black holes would likely make them very dangerous and inhospitable places, rather than gateways to new worlds. The mystery surrounding black holes continues to spark curiosity, as scientists strive to uncover the secrets of these enigmatic objects and their role in the universe. In the realm of theoretical physics, the idea of black holes functioning as portals is a fascinating concept that intertwines with several advanced theories, primarily revolving around the fabric of spacetime and the nature of gravity. One prominent framework that supports this idea is Einstein's general theory of relativity. This theory describes how mass and energy warp spacetime, creating the gravitational effects we observe. When a massive star collapses, it can form a black hole, where the gravitational pull becomes so strong that nothing, not even light, can escape. However, these extreme conditions also lead to intriguing hypotheses about what happens inside and beyond the event horizon, which is the boundary surrounding a black hole. Some scientists speculate that within a black hole, spacetime might behave in unexpected ways. Theoretical physicist Kip Thorne, among others, has suggested the possibility of wormholes, or Einstein-Rosen bridges. These are hypothetical tunnels connecting two separate points in spacetime. If a black hole is one end of a wormhole, it could, in theory, allow for travel between distant parts of the universe, or even different universes altogether. This idea captures the imagination, as it implies that black holes could serve as shortcuts through the cosmos, enabling instantaneous travel across vast distances. However, the stability of such wormholes presents a significant challenge. Most theories indicate that they would require exotic matter with negative energy density to keep them open, which has not been observed in nature. This speculative aspect leads to further discussions around quantum mechanics, where the behaviors of particles at the smallest scales might offer clues about the nature of black holes and the fabric of reality itself. Some physicists propose that black holes could also be related to concepts like holographic theory, where the information contained in a volume of space can be represented as a two-dimensional surface. This opens up exciting avenues for understanding how information might be preserved or lost in the chaotic environment of a black hole. Moreover, string theory, which aims to reconcile quantum mechanics and general relativity, introduces additional dimensions beyond the familiar three-dimensional space. In this framework, black holes might connect to other dimensions, allowing for the possibility of alternate realities. While these ideas remain highly speculative, they highlight the deep connections between black holes, the fundamental structure of the universe, and the potential for portals beyond our current understanding. As researchers continue to explore these concepts, the line between science and science fiction blurs, inviting us to ponder the mysteries of the universe and our place within it. Wormholes and black holes are fascinating concepts in the realm of astrophysics, and they create a vivid picture of the universe as a place of mystery and wonder. To understand how wormholes might relate to black holes as portals, we first need to delve into what each of these phenomena is. A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. This occurs when a massive star collapses under its own gravity at the end of its life cycle, creating an area of infinite density known as a singularity, surrounded by the event horizon, which marks the point of no return for anything that ventures too close. On the other hand, a wormhole is a theoretical bridge or tunnel between two separate points in spacetime, potentially allowing for travel between them. Think of it as a shortcut through the fabric of the universe. In theory, if such a tunnel existed, it could connect distant parts of space or even different times, making it seem like a portal to another universe. This idea stems from Einstein's theory of general relativity, which describes how mass and energy warp spacetime. Now, the intriguing connection between wormholes and black holes arises from their theoretical properties. Some scientists speculate that a black hole could be one end of a wormhole, with the other end existing in a completely different region of space or time. This means that if one were to enter a black hole, they might actually be transported through a wormhole to another location, potentially even in another galaxy. However, this idea is purely theoretical and remains unproven. The extreme gravitational forces of a black hole would likely crush anything that falls into it, making the journey through a wormhole incredibly dangerous. Moreover, the concept of wormholes raises questions about the stability of such structures. While they might exist in mathematical models, it's uncertain whether they could form naturally or if they would remain stable long enough for anything to travel through them. Some theories suggest that exotic matter, which has negative energy density, could be necessary to keep a wormhole open, but such matter has yet to be discovered. This adds another layer of complexity to the discussion. In popular culture, wormholes are often depicted as convenient shortcuts for space travel in science fiction movies and books, sparking the imagination about the possibilities of intergalactic journeys. However, in the scientific community, wormholes remain a tantalizing possibility that continues to inspire research and debate. Gravity is a fundamental force in the universe that plays a crucial role in many astronomical phenomena, including the formation of black holes. When a massive star reaches the end of its life cycle, it undergoes a supernova explosion, which occurs when the star exhausts its nuclear fuel. In this dramatic event, the outer layers of the star are expelled into space, while the core collapses under its own gravity. As the core continues to shrink, gravity intensifies to the point where it overcomes all other forces. This creates a region of space where gravity is so strong that nothing, not even light, can escape from it, leading to the formation of a black hole. The boundaries of a black hole are defined by the event horizon, which is the point of no return. Anything that crosses this boundary is pulled inexorably toward the singularity, the core of the black hole where matter is thought to be infinitely dense. The intense gravitational pull of black holes can also affect nearby stars and gas clouds, creating accretion disks of material that spiral into the black hole, emitting powerful radiation in the process. In addition to black holes, gravity is also a key player in the theorized concept of portals, often depicted in science fiction as gateways to other dimensions or parts of the universe. Some scientists speculate that if black holes are connected to wormholes, which are hypothetical passages through space-time, gravity would be responsible for shaping these structures. A wormhole, if it exists, could allow for shortcuts between distant points in the universe, although the stability of such a structure is a topic of debate. According to general relativity, gravity curves space-time, and this curvature could theoretically create pathways that link different regions of space and time. The study of gravity's influence on black holes and potential portals not only deepens our understanding of the universe but also sparks the imagination, inspiring a sense of wonder about what lies beyond our current knowledge. As researchers continue to explore these concepts, they seek to unravel the mysteries of gravity and its profound impact on the cosmos. The concept of a black hole often seems like a scene from a science fiction movie, yet it holds fascinating scientific possibilities. At the heart of a black hole lies the event horizon, the boundary beyond which nothing can escape the intense gravitational pull of the black hole. This mysterious frontier has sparked the imagination of many scientists and thinkers, leading to theories that suggest it could act as a gateway to another dimension. The idea stems from the nature of space and time, which are not just static entities but dynamic fabrics that can be warped by mass and energy. When matter falls into a black hole, it compresses into an incredibly dense point known as a singularity. The event horizon marks the point where the escape velocity exceeds the speed of light, meaning that even light cannot break free once it crosses this boundary. However, some theories propose that what happens inside the event horizon could be vastly different from our current understanding. In certain models of theoretical physics, such as string theory and the concept of wormholes, it suggested that the singularity may connect to other regions of space-time, or even other dimensions entirely. This idea posits that the event horizon could act as a sort of tunnel, leading to alternate realities or different points in time. Imagine it as a bridge that connects our universe to another, where the laws of physics might be different, or where time flows differently. Some physicists theorize that if we could somehow survive the journey through a black hole, we might emerge into a completely different universe, experiencing time and space in ways we cannot currently comprehend. Moreover, the notion of black holes as gateways has been popularized by the concept of a multiverse, where our universe is just one of many, each with its own unique properties. In this context, the event horizon could serve as a portal between these various universes. While these ideas are still highly speculative, they invite us to ponder the vastness of the cosmos and the possibilities that lie beyond our current understanding. As research continues and our technology improves, scientists are exploring the fundamental nature of black holes. They're using advanced telescopes and instruments to gather data, hoping to unlock the secrets of these cosmic phenomena. Each new discovery brings us a step closer to understanding the complexities of black holes and the potential they hold for revealing the nature of the universe itself. The interplay of gravity, time, and quantum mechanics may eventually lead to groundbreaking insights that could transform our perception of reality. In the end, while we may, the idea of a black hole acting as a portal opens up fascinating possibilities about our understanding of space-time. Traditionally, black holes are seen as regions in space where gravity is so strong that nothing, not even light, can escape from them. They are formed when massive stars collapse under their own gravity at the end of their life cycles. However, if we consider black holes as portals, this challenges our conventional views. A portal implies a connection to another point in space, or possibly even time, suggesting that black holes might not just be destructive forces but gateways to other parts of the universe or different dimensions altogether. This concept could reshape our understanding of the fabric of space-time itself, which is the four-dimensional continuum that combines the three dimensions of space with the dimension of time. According to Einstein's theory of relativity, massive objects like black holes warp spacetime around them. If black holes can act as portals, we might be able to traverse vast distances in the universe instantaneously. This leads to questions about what lies on the other side of a black hole. Are these portals leading to other galaxies, different times in the universe, or alternate realities? Moreover, if black holes are indeed gateways, this could imply that the universe is interconnected in ways we are just beginning to understand. It raises the possibility of traveling through time, which has long been a topic of science fiction, but could have real implications if we could find a way to navigate through these cosmic phenomena safely. The idea also invites us to reconsider the nature of gravity and how it behaves near and within black holes. There is ongoing research trying to understand the physics of black holes, including the famous information paradox, which questions whether information that falls into a black hole is lost forever or can somehow be recovered. If black holes function as portals, this might suggest that information does not simply disappear but is transferred to another part of the universe, further complicating our understanding of reality. The implications of these theories could lead to breakthroughs in our comprehension of quantum mechanics and general relativity, potentially unifying these two pivotal theories of physics. In addition, the idea of black holes as portals could inspire new technologies and methodologies in astrophysics, encouraging scientists to explore the behavior of matter and energy in extreme gravitational fields. This could help us unlock secrets about the universe's origins and its ultimate fate. Such explorations could also lead to advancements in our understanding of dark matter and dark energy, which make up a significant portion of the universe but remain largely. Exploring the idea of black holes as portals is fascinating and stretches our imagination about the universe. If black holes were confirmed to be portals, the laws of physics as we understand them might undergo significant changes. Currently, black holes are regions in space where gravity is so strong that nothing, not even light, can escape. They are often seen as the ultimate traps of the cosmos, but the portal theory suggests a more dynamic role for these mysterious entities. For instance, if black holes acted as gateways to other points in space or even different dimensions, it would challenge our understanding of space-time. According to Einstein's theory of relativity, space and time are intertwined, and the presence of mass can warp this fabric. If black holes could connect with other points in the universe, we might need to revise our theories about the speed of light and how we perceive distance. Imagine that traveling through a black hole could allow for instant travel across vast distances, making the universe feel smaller. This concept could open up discussions about wormholes, which are theoretical passages through space-time. In this scenario, the rules governing gravity and energy might also shift, as the energy needed to traverse such a portal could defy our current understanding of physics. Moreover, the implications for causality, how cause and effect work, would be immense. If you could step into a black hole and emerge in another part of the universe, questions would arise about what happens to time during that journey. Would you age differently? Would events in one place affect those in another instantaneously? Furthermore, the existence of portals could lead to new types of particles or forces we have yet to discover. These could interact with matter and energy in ways that could create new technologies or even challenge our fundamental concepts of reality. The idea of multiple universes also comes into play, suggesting that each black hole could lead to a different universe altogether. This would not only revolutionize our understanding of black holes but also of the universe itself, as we began to explore the idea that what we perceive as our own universe might be just one of many, interconnected through these mysterious gateways. As we delve deeper into these possibilities, scientists would have to reconsider the very nature of gravity, potentially leading to a unified theory that combines quantum mechanics and general relativity. This could provide explanations for phenomena we currently find puzzling, like dark matter and dark energy. The laws of physics, as we know them, might be just the beginning of a more complex and interconnected. Exploring black holes as potential portals into other realms of the universe is an exciting concept that captures the imagination. To embark on such a journey, we would need several technological advancements that bridge the gap between our current understanding of physics and the complex nature of black holes. First and foremost, we would require highly advanced spacecraft capable of withstanding the extreme gravitational forces present near a black hole. These spacecraft would need to be constructed from materials that could endure immense pressure and radiation, which are typical in the vicinity of these cosmic giants. Next, we would need highly sophisticated propulsion systems that can achieve the incredible speeds necessary to approach a black hole safely. Current propulsion technology, like chemical rockets, would be insufficient, so innovations such as ion propulsion or even theoretical concepts like warp drives, which could bend space-time, would be essential in making this journey feasible. Additionally, we would require advanced navigation systems that can accurately plot a course through the unpredictable gravitational field surrounding a black hole, ensuring that we could avoid being pulled in irreversibly. Moreover, we would need to develop new methods of communication that could function in the extreme conditions near a black hole. Traditional signals might be distorted or lost entirely, so technologies capable of transmitting information through gravitational waves or using quantum entanglement might become vital for maintaining contact with Earth or other spacecraft. To better understand the nature of black holes and the potential for portals, we would also benefit from advancements in observation technologies. Powerful telescopes and detectors capable of observing high-energy phenomena, such as Hawking radiation, could provide insights into the behavior of matter and energy near black holes. These observations could help us unravel the mysteries of how black holes might act as gateways to other dimensions or even other points in time. Lastly, a deeper understanding of theoretical physics, particularly in the realms of quantum mechanics and relativity, would be crucial. This could involve developing new mathematical models or simulations that could predict what happens when matter interacts with a black hole's event horizon. Only with a solid theoretical foundation can we hope to devise practical applications for these cosmic phenomena. In summary, the quest to explore black holes as portals requires a multidisciplinary approach that combines advanced engineering, innovative propulsion methods, improved communication systems, cutting-edge observational tools, and a deeper understanding of the fundamental laws of physics. As we continue to push the boundaries of our knowledge, the idea of venturing into the unknown through black holes remains a tantalizing possibility on the horizon of scientific exploration. The existence of black hole portals could revolutionize space travel and exploration in ways we can only begin to imagine. If black holes could serve as portals or shortcuts between distant points in the universe, traveling vast distances would become much more feasible. Instead of spending years or even centuries traveling to other stars with our current technology, we could potentially leap through these portals and arrive at our destination almost instantaneously. This kind of travel would open up the galaxy, allowing humans to explore planets that are currently light years away, making the dream of interstellar exploration a reality. Moreover, the energy dynamics of black holes are incredibly fascinating. They possess immense gravitational pulls, and scientists speculate that if we could harness the energy surrounding a black hole, we could develop advanced propulsion systems. These systems might allow spacecraft to travel at speeds far beyond anything we can achieve today, possibly even approaching the speed of light. This concept aligns with theories suggesting that tapping into the energy of a rotating black hole, known as the Penrose process, could provide a near unlimited source of power. The implications for research would be significant as well. Imagine sending probes through black hole portals to gather data from regions of space that are currently unreachable. We could study environments that are completely alien to us, discovering new forms of life, unique planetary systems, and even gaining insights into the fundamental questions of the universe, such as the nature of dark matter and dark energy. However, there would also be challenges and risks associated with this kind of travel. Black holes are surrounded by regions known as event horizons, where gravity becomes so strong that nothing, not even light, can escape. Navigating these regions safely would require advanced technology and a deep understanding of astrophysics. Additionally, the unpredictable nature of black holes raises questions about the safety of traveling through them. If we were able to establish a network of black hole portals, we might create a new frontier for humanity, akin to the age of exploration on Earth when sailors ventured into uncharted waters. This could lead to a new era of discovery, where not only scientists but also everyday people could participate in space exploration. The idea of traveling to other star systems, experiencing different worlds, and perhaps even encountering extraterrestrial life could transform our understanding of our place in the universe. In summary, the existence of black hole portals could significantly enhance our capacity to explore space, leading to breakthroughs in technology, energy resources, and our understanding of the cosmos. It presents a thrilling possibility for traveling through a black hole portal presents a range of dangers that are both fascinating and terrifying. First, it's essential to understand that black holes are regions in space where gravity is so strong that nothing, not even light, can escape. This incredible gravitational pull is created when a massive star collapses under its own weight. If a traveler were to approach a black hole, they would encounter an event horizon, which is the point of no return. Once crossed, escape becomes impossible. The intense gravitational forces near this boundary could stretch and compress anything that gets too close, a phenomenon known as spaghettification. Imagine being pulled apart like a strand of spaghetti as the black hole's gravity differs significantly from one part of your body to another. Moreover, the journey through a black hole might expose travelers to extreme radiation. Since black holes often have accretion disks, rings of gas and dust spiraling into them, these disks can emit high-energy radiation. This radiation can be harmful, potentially damaging living cells and causing severe health issues if one were to survive the initial journey. Additionally, the unpredictable nature of black holes adds another layer of danger. The laws of physics as we understand them break down near a black hole, leading to situations that are difficult to predict or comprehend. Traveling through a black hole might also lead to encountering a singularity, a point at the center where density becomes infinite. The very concept of time and space loses its meaning there, which raises questions about what happens to an object or a person that reaches this point. Would they be crushed, or could they end up in another universe altogether? These unknowns make the prospect of traveling through a black hole not only dangerous, but also filled with uncertainty. Moreover, even if one could theoretically survive the journey through such a portal, there is the question of where they would end up. Some theories suggest that black holes could be wormholes, connecting different parts of the universe or even different universes entirely. However, the stability of such a passage is uncertain. If the wormhole were to collapse while one was traveling through it, it could lead to tragic consequences, possibly trapping the traveler in a void with no way to return. In addition to these physical dangers, the idea of isolation also looms large. Traveling through a black hole could lead to a complete disconnection from known space, leaving a traveler utterly alone and cut off from communication with the outside world. The psychological effects of such isolation, combined. Time dilation is a fascinating concept that comes from Einstein's theory of relativity, and it becomes especially intriguing when we consider the extreme environment of a black hole. As an object approaches a black hole, the gravitational pull becomes incredibly strong, and this intense gravity causes time to behave in unusual ways. For someone who might hypothetically enter a black hole portal, the experience of time could be drastically different from what we understand in our everyday lives. Imagine a person falling into a black hole. To an outside observer watching from a safe distance, it would seem as if this person is moving slower and slower as they get closer to the event horizon, the point of no return surrounding the black hole. This happens because the gravitational field is so strong that it stretches time. Consequently, the falling individual would appear to freeze in time, almost suspended in the moment, while the universe around them continues to move forward at its usual pace. However, from the perspective of the person entering the black hole, their experience of time would be quite different. As they cross the event horizon, they would not notice any dramatic change at that moment. Time for them would continue to flow normally, but as they delve deeper into the black hole, the effects of time dilation become even more pronounced. The deeper they go, the more they would experience a significant difference in how time is perceived compared to the outside universe. In this bizarre scenario, while only a few minutes might pass for the person inside the black hole, countless years could elapse in the outside world. This raises profound questions about the nature of time in reality. Would they witness the distant future of the universe as they fall deeper? Would they encounter different timelines or realities? These questions linger because the laws of physics as we know them break down at the singularity, the core of the black hole, where density becomes infinite and the known rules of time and space cease to apply. The implications of such time dilation extend beyond mere curiosity. They challenge our fundamental understanding of time itself. It pushes the boundaries of physics and invites us to consider not just the mechanics of the universe, but also the philosophical implications of experiencing time in such a radically different way. As we ponder these mysteries, we can't help but marvel at the wonders of the universe and how much we have yet to discover about the intricate dance of time, space, and gravity, particularly in the enigmatic realm of black holes. To explore the idea of black holes being portals, scientists would look for several types of evidence that could support this fascinating concept. First, they would examine the behavior of matter and energy around black holes. If black holes truly act as portals, we might expect to see unusual patterns in how stars and gas behave as they approach these mysterious objects. For instance, if matter appears to vanish into a black hole but then reemerges elsewhere in the universe, it could suggest a connection to another dimension or location. Scientists might also analyze the gravitational waves produced during black hole mergers. If these waves exhibit strange signatures, it could hint at a deeper, more complex reality involving portals. Additionally, researchers would utilize advanced telescopes to observe any anomalies in the cosmic microwave background radiation, which is the afterglow of the Big Bang. If black holes are gateways to other parts of the universe, they might leave unique imprints or distortions in this radiation, acting as clues to their true nature. Furthermore, scientists would study the information paradox, which arises when matter falls into a black hole. If information can escape a black hole in some form, it might indicate a pathway or connection to other regions in space-time, aligning with the idea of portals. Theoretical physicists would also delve into the realm of quantum mechanics, looking for evidence that could link black holes to quantum entanglement or wormholes. This would involve examining the fundamental principles of how particles interact at the quantum level. If black holes can somehow connect different points in space-time, it could revolutionize our understanding of the universe and its structure. Finally, ongoing research into dark matter and dark energy might uncover relationships between these mysterious components of the universe and black holes, providing further insight into their potential as portals. As scientists gather data from various observations and experiments, they will continue to piece together the puzzle of black holes, striving to determine whether these enigmatic entities could indeed serve as gateways to other realms or dimensions. The discovery of black holes as portals could revolutionize our understanding of the universe in many fascinating ways. Imagine if these mysterious cosmic entities, often viewed as points of no return, were actually gateways to other regions of space and time. This idea challenges our current perception of black holes as merely destructive forces. Instead, they could be seen as bridges connecting different parts of the universe, or even different universes altogether. If we consider this possibility, it opens up a realm of questions regarding the nature of dimensions and the fabric of reality itself. Such a discovery would imply that the universe is interconnected in ways we have yet to comprehend. It could lead to new theories about the origins of the universe and its expansion. Perhaps black holes serve as conduits for energy and matter, allowing for the transfer of information across vast distances. This could mean that the universe is not as isolated as we might think, but rather a vast network of interlinked regions. Additionally, if black holes are portals, they might offer insights into the nature of time. Instead of being linear, time could bend and twist in ways that allow for travel across epochs. This poses intriguing possibilities for both scientific exploration and the understanding of time itself. It raises the question of whether time travel could be possible, and what implications that would have for our understanding of history and the future. Moreover, the existence of black holes as portals could lead to a reevaluation of the laws of physics. Currently, theories such as general relativity and quantum mechanics govern our understanding of the universe, but merging these two fields has proven challenging. Portals might provide the key to unifying these theories, potentially revealing a more comprehensive framework that explains everything from the smallest particles to the vast structure of the cosmos. Furthermore, such a discovery would spark a new wave of curiosity and exploration. Scientists and researchers would focus their efforts on studying these black hole portals, leading to advancements in technology and our understanding of fundamental forces. The quest to unlock the secrets of these cosmic gateways could inspire a new generation of astronomers, physicists, and enthusiasts eager to learn more about the universe and our place within it. This shift in perspective could also enhance our appreciation of the universe's complexity and beauty. As we realize that black holes may serve as bridges to other realms, the idea of a solitary universe becomes less appealing. Instead, the cosmos could be viewed as a rich tapestry of interconnected threads, each leading to different experiences, worlds, and possibilities. Quantum mechanics, a branch of physics that deals with the behavior of very small particles, introduces fascinating ideas that can stretch our understanding of black holes and their potential role as portals. Black holes, which are regions in space where gravity is so strong that nothing, not even light, can escape, have long been a subject of scientific curiosity and speculation. The concept of black holes as portals arises when we consider how quantum mechanics might interact with the extreme conditions present in these cosmic phenomena. In classical physics, black holes are viewed as one-way streets where anything that crosses the event horizon, the point of no return, gets trapped forever. However, quantum mechanics suggests that particles can exist in multiple states at once, a phenomenon known as superposition. This opens up intriguing possibilities, as some theories propose that if a particle could enter a black hole, it might not just disappear, but could instead be transformed in a way that allows it to emerge somewhere else in the universe, possibly even in another universe altogether. One of the key ideas in this area is the concept of wormholes, which are hypothetical passages through spacetime that could connect distant regions of the universe. These wormholes are often associated with black holes, and quantum mechanics could provide the mathematical framework to understand how they might work. The idea is that if a black hole could be stable enough, and if quantum effects allowed for the formation of such a connection, it might act as a portal, letting matter travel across vast distances instantaneously. Moreover, quantum entanglement, a phenomenon where particles become linked in such a way that the state of one instantly influences the state of another, no matter the distance, adds another layer of complexity. If black holes can entangle particles on either side of their event horizons, this could suggest a form of communication or connection between regions of space that are otherwise separated by immense distances. Additionally, the infamous Hawking radiation, predicted by physicist Stephen Hawking, proposes that black holes can emit radiation due to quantum effects near the event horizon. This radiation suggests that black holes are not entirely black but can lose mass over time, leading to the possibility that information might escape from a black hole. This has led to debates about whether information that falls into a black hole is permanently lost or if it can be retrieved, further fueling the idea of black holes as potential gateways to other realms of the universe. While these concepts remain largely theoretical and are the subject of ongoing research, they highlight the profound implications that quantum mechanics might have on our black holes, often seen as mysterious and fascinating objects in the universe, are not only the endpoint for massive stars, but also the subject of many theories regarding their connection to different regions of space. The idea of black holes acting as portals is intriguing and stems from the nature of their gravitational pull and the warping of spacetime. When matter falls into a black hole, it is believed to be compressed to an infinite point known as a singularity. Surrounding this singularity is the event horizon, the point of no return, beyond which nothing can escape, not even light. This extreme gravitational field can warp spacetime in such a way that it may create shortcuts through the fabric of the universe, which some scientists theorize could connect distant points in space or even different times. The concept of these black hole portals is often tied to the idea of wormholes, which are hypothetical passages through spacetime that could allow for travel between different regions of the universe. If one could enter a black hole, it is speculated that you might emerge from a wormhole at another location or even in another universe entirely. This fascinating notion raises questions about the potential for interstellar travel and the limits of our understanding of physics. However, the reality is that we have yet to observe any definitive evidence of such portals existing, and the extreme conditions near a black hole make it nearly impossible for any known form of matter to survive the journey. Additionally, black holes can vary in size and characteristics, with some being stellar black holes formed from collapsing stars, while others are supermassive black holes residing at the centers of galaxies. The way these black holes interact with their surroundings may also play a role in the theory of portals. For instance, when black holes consume nearby stars or gas, they emit powerful jets of energy and matter that can influence the surrounding space, potentially affecting the structure of spacetime itself. While this remains largely within the realm of theoretical physics, the idea of black holes as portals inspires both scientists and science fiction enthusiasts alike. It encourages exploration into the nature of the universe and the fundamental laws that govern it, inviting a sense of wonder about what lies beyond our current understanding and whether there might be ways to traverse the vast distances of space in ways we have yet to discover. The study of black holes and their potential as cosmic gateways continues to be a thrilling frontier in the quest for knowledge about the universe and our place within it. Exploring the idea of black holes and the destinations they might lead to is a fascinating journey into the mysteries of the universe. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape from them. This extreme gravitational pull occurs when a massive star collapses at the end of its life cycle, creating a singularity at its core, surrounded by an event horizon. The concept of using black holes as portals to other destinations has captured the imagination of scientists and fiction lovers alike. If you could somehow traverse a black hole, what could lie on the other side? One theory suggests that black holes might connect to other parts of our universe. This means that if you could survive the intense gravitational forces and somehow enter a black hole, you might emerge in a completely different location in space, potentially light years away from where you started. Imagine traveling from one galaxy to another in the blink of an eye, experiencing the wonders of distant stars and planets that have never been seen before. Another exciting possibility is that black holes could lead to alternate dimensions or parallel universes. Some physicists theorize that our universe may be just one of many, existing in a vast multiverse. If a black hole serves as a portal, it might take you to a universe with different physical laws, where time flows differently or where other forms of life exist. The idea of encountering entirely new realities is both thrilling and daunting, as it raises questions about the nature of existence itself. There are also theories related to wormholes, which are hypothetical passages through space-time that could connect distant parts of the universe or even different universes. Some scientists believe that black holes could be the entrances to these wormholes, offering a shortcut across the cosmos. If such connections exist, they might allow for instantaneous travel between 2 points in space, making it possible to reach parts of the universe that are otherwise unreachable with our current technology. While these ideas are largely theoretical and come from advanced physics, they open the door to endless possibilities. Speculations about what lies beyond a black hole fuel both scientific inquiry and creative storytelling, leading to countless tales of adventure and exploration. The thought of venturing through a black hole encourages us to think about the universe in ways we never have before, challenging our understanding of space, time, and reality. As we continue to learn more about black holes, we can't help but wonder what secrets they hold and what incredible destinations might await those brave enough to explore there. Imagine a universe where black holes, those mysterious and powerful cosmic phenomena, could act as portals for communication. While black holes are known for their intense gravity that pulls everything in, scientists have proposed that they might also serve as gateways to other parts of the universe. The idea centers around the concept of wormholes, theoretical passages that could link 2 points in space and time. If a black hole could be connected to a wormhole, it might allow for the transfer of information across vast distances, far beyond what we currently consider possible. In this scenario, information could be sent into one end of the black hole and, through the wormhole, emerge from another black hole situated light years away. This means that a message could travel across the universe in a fraction of the time it would take light to make the same journey. Theoretically, if someone created a way to encode messages into forms of energy or particles, they could send these signals into a black hole and retrieve them from another location. However, this concept raises many questions. For example, would the information survive the intense gravitational forces of the black hole? And how would we know where to send the message to ensure it comes out the other end? Interestingly, some studies in quantum physics suggest that information might not be lost when it enters a black hole, as once thought. Instead, it could be preserved in some form, potentially allowing us to retrieve it later. This idea is still highly speculative, but it opens exciting possibilities for how we might one day communicate over unimaginable distances. Just imagine being able to send a message from Earth to a star system hundreds of light years away in just moments. The implications for science, exploration, and even the search for extraterrestrial life are enormous. Could we send our thoughts, images, or even sounds through these cosmic gateways? While we are far from turning this science fiction into reality, the concept of using black holes as communication portals challenges our understanding of physics and the universe itself. It inspires curiosity and pushes the boundaries of what we think is possible, making us wonder about the secrets that lie beyond our reach in the vastness of space. The concept of black holes as portals opens up a fascinating realm of philosophical questions that challenge our understanding of reality, time, and existence. One of the primary questions is whether these black holes actually serve as gateways to other dimensions or universes. If this is true, it raises the idea of what lies beyond our observable universe. Could there be alternate realities, or even entirely different laws of physics governing them? This leads us to ponder the nature of existence itself. If a person or object were to enter a black hole and emerge elsewhere, would they still be the same entity? Would their consciousness remain intact, or would the experience fundamentally alter their identity? Another intriguing question is about the nature of time within and around a black hole. According to Einstein's theory of relativity, time behaves differently in the presence of intense gravitational fields, such as those created by a black hole. If black holes can bend time, what does that mean for our understanding of cause and effect? Could traveling through a black hole allow one to experience events in reverse or leap forward into the future? This challenges our linear perception of time and leads to profound inquiries about fate and free will. If one could theoretically manipulate time, would our choices still hold significance? The ethical implications of such travel are also worth considering. If black holes are indeed portals, what responsibilities would come with the ability to traverse them? Would it be ethical to explore or exploit other universes? Furthermore, if we were to encounter other forms of life or intelligence in these realms, how should we interact with them? This raises questions about our role in the cosmos and the potential consequences of our actions on a universal scale. Additionally, the very idea of black holes as portals forces us to confront the limits of human knowledge and understanding. Are there aspects of the universe that we can never fully comprehend? If black holes lead to places beyond our current scientific reach, does that mean there are fundamental truths about existence that remain forever elusive? This touches on the philosophical debate between determinism and chaos, as the unpredictable nature of black holes challenges our ability to fully grasp the universe's workings. In considering the implications of black holes as portals, we also engage with the nature of reality itself. Is what we perceive as reality merely a thin veil over a far more complex and interconnected universe? Each question builds upon the last, creating a tapestry of inquiry that highlights our insatiable curiosity about the cosmos and our place within it. As we continue to explore these astronomical phenomena, the discovery of black holes being used as portals would likely evoke a whirlwind of reactions from humanity, blending excitement, fear, and curiosity. Scientists and physicists would be at the forefront, eager to explore the implications of such a finding. They would rush to create theories and conduct experiments to understand how these cosmic phenomena could function as gateways to other locations in the universe, or even other dimensions. The scientific community would likely collaborate on a global scale, pooling resources and knowledge to develop technologies that could safely investigate these portals. Public interest in space and astrophysics would skyrocket, leading to an influx of educational programs and media focusing on black holes and their mysterious nature. Documentaries, articles, and online content would flood platforms, explaining the science behind black holes, their formation, and the potential for interstellar travel. The general public's fascination might also inspire a new generation of young scientists and engineers, eager to unravel the mysteries of the universe. On the other hand, the concept of black holes as portals would also raise significant ethical and safety concerns. Governments and international organizations might engage in heated debates about the potential risks involved in utilizing such portals. Questions about what lies on the other side, the possibility of encountering unknown and possibly dangerous entities, and the impact on our own planet would dominate discussions. Safety protocols would be paramount, and the idea of sending humans or machines through black holes would necessitate rigorous testing and planning. The military could become involved, considering the strategic advantages of such technology. They might explore the potential for using black hole portals for rapid transportation, or even as a means of defense against potential extraterrestrial threats. This involvement could lead to public outcry and fears surrounding the militarization of space, prompting protests and calls for transparency regarding the research and its applications. Philosophers and ethicists would also weigh in, pondering the implications of such discoveries on our understanding of existence and the universe. Would humanity be ready to confront the realities of life beyond Earth? Would the existence of these portals challenge our beliefs about time, space, and our place in the cosmos? These questions would spark debates, lectures, and discussions in academic circles and beyond. As the idea of black holes as portals settles into public consciousness, various forms of media, from literature to film, would likely capitalize on the concept, portraying both the wonders and dangers of interdimensional travel. This could lead to a boom in science fiction, exploring themes of exploration, adventure, and the unknown. The cultural impact would be significant. Imagine a world where black hole portals exist, allowing us to travel vast distances across the universe. This intriguing concept could change our understanding of space and time, but it would also have profound cultural implications for society. As people learn about the possibility of stepping into a black hole and emerging in another part of the galaxy, our views on exploration and adventure would shift dramatically. The idea of venturing into the unknown would become more appealing, igniting a new sense of curiosity about the cosmos. This desire for exploration might lead to new forms of storytelling and art, as writers and artists begin to create works that reflect the experiences of intergalactic travel. Imagine books, movies, and paintings that capture the emotions of stepping through a black hole, the sights of distant worlds, and the encounters with alien life. Additionally, this newfound fascination with the universe could inspire scientific endeavors, encouraging more people to pursue careers in astronomy, physics, and engineering. On a social level, the existence of black hole portals might foster a sense of global unity. As people from different backgrounds come together to explore the cosmos, the barriers created by geography and culture could begin to dissolve. We might find ourselves more connected, sharing experiences of travel and discovery that transcend earthly borders. However, this could also lead to challenges, such as debates over who gets to use these portals and how they should be regulated. The implications could extend to our philosophical and spiritual beliefs as well. Many cultures have different views on the universe and our place within it. The ability to travel through black holes might provoke discussions about existence, destiny, and the nature of reality itself. Some might interpret these portals as gateways to new realms, while others could see them as a threat to traditional beliefs. Moreover, the idea of black hole portals could influence our environmental consciousness. If we have the ability to travel beyond our planet, it might encourage us to think more critically about the care of Earth. Would we see it as a precious home that we must preserve, or as just one of many places to inhabit? This could lead to a growing movement focused on sustainability and conservation, as people recognize the importance of taking care of our own planet while exploring new worlds. In education, the existence of black hole portals could reshape curricula, with schools emphasizing astrophysics, cosmology, and the potential for space travel. Young minds would be captivated by the possibilities that lie beyond the stars, possibly inspiring generations to dream bigger and reach further. Ultimately, throughout history, various civilizations have looked to the stars, fascinated by the mysteries of the universe, including black holes. While black holes are regions in space with gravity so strong that nothing, not even light, can escape, the idea of using them as portals is a captivating concept often explored in science fiction and theoretical physics. Different civilizations, with their unique perspectives and technological advancements, might envision utilizing black holes in diverse ways. Imagine an advanced civilization that has mastered the ability to manipulate gravitational forces. They could theoretically create a spacecraft designed to enter a black hole's event horizon, the point of no return, and emerge in a different part of the universe, or even in a parallel dimension. This concept relies on the idea that black holes might connect to wormholes, which are theoretical passages through spacetime. In ancient cultures, black holes could have been interpreted as gateways to the afterlife or other realms, leading to various mythologies about cosmic journeys. For instance, a civilization might build elaborate rituals around celestial events that coincide with black holes, believing that these events are moments when the barriers between worlds are thinnest. The spiritual significance attributed to such phenomena could influence their architecture, astronomy, and art, incorporating themes of travel between realms that the black holes represent. As humans began to explore the cosmos through science, the idea evolved. A futuristic society dedicated to space exploration could develop technologies that harness the energy emitted from black holes, using it to power their ships or even create artificial wormholes. They might discover that by sending probes into black holes, they could gather vital information about the structure of the universe, potentially finding shortcuts across vast distances. This kind of innovation could revolutionize interstellar travel, allowing for faster-than-light journeys that were once thought impossible. In another scenario, civilizations might develop a deep understanding of quantum physics and the nature of black holes, leading them to create devices that can manipulate space-time. These devices could allow them to send messages or even physical objects through black holes to distant locations in a matter of moments. This advancement could facilitate communication across galaxies, fostering collaboration and cultural exchange among different species. The idea of black holes as portals also raises intriguing questions about time travel. If a civilization could navigate the complex physics of a black hole, they might unlock the potential to travel not only across space but also through time. This could lead to rich narratives about altering the past or witnessing the future as societies explore the implications of their actions across different timelines. Furthermore, if black holes were portals, it would dramatically alter our understanding of the universe and reality itself. Traditionally, black holes are seen as regions of space where gravity is so intense that nothing, not even light, can escape. This leads to the idea that they are the end points of matter, sucking everything in and leaving behind a void. However, if we imagine black holes as gateways to other dimensions or distant parts of the universe, it opens up fascinating possibilities. We might consider that instead of being dead ends, black holes could be like tunnels connecting different areas of space-time. This concept challenges our current notions of space and time, suggesting that reality might be far more complex than we perceive. Instead of a linear experience of time and space, we could envision a web of interconnected portals, allowing for instantaneous travel across vast distances. Imagine being able to step into a black hole and emerge in another galaxy, or even another time. This could imply that our universe is just one of many, each connected through these cosmic gateways. Moreover, if black holes functioned as portals, it would raise questions about the nature of existence itself. What would happen to the matter and energy that enters a black hole? Would it be transformed, destroyed, or perhaps transported to some other realm? The implications stretch into the realms of philosophy and science, suggesting that our reality could be more fluid and dynamic than static. Furthermore, the idea of black holes as portals could potentially lead to new discoveries in physics, prompting scientists to rethink theories about gravity, quantum mechanics, and the fabric of space-time. It might inspire a new generation of explorers, both in terms of theoretical research and practical exploration of black holes, pushing the boundaries of what we deem possible. In a more imaginative context, this perspective could also influence how we view our place in the universe. If black holes are not just destructive forces but rather opportunities for exploration and connection, it might encourage a greater curiosity about the cosmos and our relationship with it. This could lead to a more profound appreciation for the mysteries of the universe and the potential for discovery that lies beyond our current understanding. The implications are not just scientific but also cultural, potentially reshaping storytelling, art, and our collective imagination about space and existence. The idea of black holes as portals invites a sense of wonder and possibility, challenging us to think beyond the limits of our current knowledge and explore what lies beyond the horizon of our understanding. Black holes are some of the most fascinating objects in the universe, capturing our imagination with their mysterious nature. They are regions in space where gravity is so strong that nothing, not even light, can escape their pull. When we think about black holes, we often picture their immense gravitational force, but they also raise questions about the fundamental rules of physics, particularly regarding causality. Causality, in simple terms, is the relationship between cause and effect, where an event, the cause, leads to another event, the effect. Now, imagine if black holes could act as portals, connecting different points in space and time. This idea has been explored in both science fiction and theoretical physics. If we were to consider black holes as portals, it could mean that traveling through one might allow an object or even a person to emerge at a different point in the universe, or even in a different time. This concept challenges our traditional understanding of causality. For instance, if someone were to travel back in time through a black hole, they could potentially alter events that have already happened, which leads to paradoxes. What happens if a time traveler were to prevent their own existence? Such scenarios create a tangled web of cause and effect that seems to defy logic. Moreover, this idea also ties into the concept of wormholes, which are theoretical passages through space-time that could create shortcuts between distant parts of the universe. If black holes are connected to wormholes, the implications for causality become even more complex. Imagine two events happening simultaneously in different locations, but due to the connection through a wormhole, they could influence each other in unexpected ways. This interconnectedness might suggest that our understanding of linear time, where one event leads directly to another, could be overly simplistic. Scientists are still grappling with these concepts, trying to reconcile the laws of physics with the strange properties of black holes. The idea that black holes could be portals raises questions about the nature of reality itself. Are there multiple timelines or alternate realities that could be accessed through these cosmic phenomena? If so, how would that affect our understanding of time, space, and the very fabric of the universe? As researchers continue to study black holes, they also delve into the fundamental laws of quantum mechanics and general relativity, seeking to find a unified theory that could explain all these puzzles. The exploration of black holes and their potential as portals not only opens up new avenues in astrophysics, but also invites us to rethink our place. Imagine a universe where multiple black holes act as portals, connecting different parts of space and time in ways we can only begin to understand. The potential consequences of such a phenomenon could be profound and far-reaching. First, consider the gravitational effects. Black holes are known for their intense gravitational pull, and if they were to serve as portals, they could warp the fabric of space around them. This could lead to unpredictable gravitational interactions, affecting nearby stars and planets, perhaps even pulling them into these portals or flinging them into distant regions of the universe. The existence of portals could also challenge our understanding of physics. If one could travel through a black hole, the rules of space and time as we know them might break down. This would raise questions about causality, suggesting that events could occur out of order or that actions taken in one part of the universe could instantly affect another, distant location. Such a scenario would open up fascinating discussions about time travel, alternate realities, and the very nature of existence. Moreover, the discovery of black hole portals could lead to an exploration boom. Just as early explorers set sail to discover new lands, future scientists and adventurers might be inspired to venture into these cosmic gateways. This could lead to breakthroughs in our understanding of not only the universe, but also the fundamental laws of nature. However, with such exploration comes risks. The environments surrounding black holes are extreme, and even a slight miscalculation could result in disastrous consequences, such as being pulled into oblivion. Additionally, multiple black holes acting as portals could have an impact on cosmic structures. Galaxies could become interconnected, allowing for the easy movement of matter and energy across vast distances. This could lead to the formation of new celestial bodies and possibly even affect the evolution of life in different parts of the universe. If planets were to connect through these portals, it might create unique ecosystems where life forms could interact in ways we have never seen before. Yet, there is also the potential for danger. If black holes were to serve as portals, they could become conduits for unknown cosmic entities. This could lead to the introduction of new forms of life or even hostile forces into our own galaxy. The balance of ecosystems could be disrupted, leading to extinctions or the rise of invasive species. The implications of multiple black holes as portals could extend to our own species too. Imagine the possibility of humans traveling through these gateways to explore new worlds or even to communicate with intelligent life forms on other planets. Black holes and portals are fascinating topics that have captivated the imagination of many science fiction writers and creators. In literature and film, black holes are often depicted as mysterious cosmic phenomena that can warp space and time, creating a sense of wonder and fear. For instance, in the novel Interstellar by Christopher Nolan, the story revolves around space travel through a black hole, showcasing how it could potentially lead to different dimensions or time periods. This gives readers a glimpse into the possibilities of advanced physics, even if it stretches beyond our current understanding. Similarly, portals serve as gateways to other worlds, dimensions, or times, providing an intriguing plot device that allows characters to embark on extraordinary adventures. In C.S. Lewis's The Chronicles of Narnia, the wardrobe acts as a portal to a different realm, illustrating how portals can transport characters from the mundane to the magical. This concept of portals highlights the idea of exploration and the endless possibilities that lie beyond our own reality. In films like Doctor Strange, portals are visual spectacles that not only serve as a means of travel, but also play a crucial role in the storyline, allowing characters to navigate complex alternate realities. This use of portals often raises questions about the nature of reality and the consequences of crossing into different dimensions. Moreover, black holes and portals frequently embody themes of the unknown, representing both danger and opportunity. In Event Horizon, a horror science fiction film, a black hole serves as both a plot device and a symbol of humanity's hubris in exploring the unknown. The idea that something as powerful as a black hole could lead to unimaginable horrors or profound discoveries adds depth to the narrative, making it more than just a simple adventure story. These themes resonate with audiences who are curious about the universe and the potential for life beyond Earth. They evoke a sense of excitement and intrigue, prompting viewers and readers alike to ponder the possibilities that black holes and portals represent. Through science fiction, we explore not only the vastness of space, but also the boundaries of human understanding, imagination, and the quest for knowledge. As we dive deeper into these stories, we find ourselves questioning our place in the universe and the mysteries that still lie ahead. Gravitational waves are ripples in the fabric of spacetime that are caused by massive objects accelerating, like colliding black holes or neutron stars. When these colossal bodies interact, they create disturbances that can travel across the universe, eventually reaching us here on Earth. Now, imagine if there were black holes that acted as portals, connecting different regions of space or even different points in time. The presence of such portals would significantly affect the propagation of gravitational waves. If a gravitational wave were to encounter a black hole portal, it might be altered in several ways. For instance, as the wave approaches the event horizon of a black hole, the extreme gravitational field would cause the wave to stretch and shift in frequency. This phenomenon is similar to what happens to light near a black hole, a process called gravitational redshift. If the gravitational wave manages to pass through a black hole portal, it could emerge in another part of the universe, potentially with changes to its amplitude and frequency, making it different from its original form. Moreover, the nature of black hole portals could create unique patterns of gravitational waves. If multiple black holes were interconnected through these portals, the waves could bounce between them, creating a complex web of interactions. This could lead to a rich tapestry of gravitational wave signatures that scientists would need to decipher. The implications are vast. We could gain insights into the structure of the universe and the nature of black holes themselves. Furthermore, these interactions might allow for the possibility of detecting gravitational waves from events that would normally be too distant or faint for us to observe. If a gravitational wave were generated in one part of the universe and traveled through a black hole portal, it could be redirected to a region where we have better observational capabilities. This would enhance our understanding of cosmic events and the underlying physics governing them. In essence, black hole portals could serve as cosmic highways for gravitational waves, transforming the way we detect and study these fascinating phenomena. The exploration of such concepts pushes the boundaries of our understanding, offering tantalizing glimpses into the mysteries of the universe and the complex interactions between gravity, space, and time. The idea of using black holes as portals is a fascinating concept often explored in science fiction, but it raises intriguing questions about potential ecological impacts, especially when we think about the delicate balance of ecosystems on Earth. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. If we were to imagine black holes as gateways to other parts of the universe, we need to consider how such a massive force could affect our planet and its wildlife. First, let's think about the gravitational forces at play. If a black hole were to be used as a portal, it could potentially alter gravitational fields in the vicinity. This could lead to disruptions in Earth's orbit or the orbits of satellites, affecting communication systems that many animals rely on for navigation. Birds, for example, use the Earth's magnetic field for migration, and any significant changes could confuse their navigation, leading to widespread disorientation and possibly impacting breeding patterns. Moreover, if portals created by black holes connected to other dimensions or worlds, the introduction of foreign species could pose a threat to local ecosystems. Invasive species can disrupt food chains, compete with native animals for resources, and even introduce diseases that local wildlife may not have immunity against. Such scenarios could lead to the decline or extinction of some species, drastically altering the biodiversity we see today. Additionally, the energy emitted from black holes, particularly during their formation or when matter is drawn into them, can be incredibly chaotic. This energy could potentially create extreme environmental conditions, such as intense radiation or temperature fluctuations, that might make certain habitats uninhabitable for many forms of life. For instance, a sudden surge of radiation could affect not only terrestrial animals but also those in aquatic ecosystems, leading to mass die-offs or mutations. Another aspect to consider is the effect on food webs. If black holes acted as portals to other areas where different ecosystems exist, the balance of predator and prey could be disrupted. For example, if a predatory species from another world were to enter our ecosystem, it could outcompete local predators, leading to a collapse of local populations and affecting other species that rely on those predators for survival. The cascading effects could ripple through the ecosystem, resulting in significant changes in species diversity and abundance. Lastly, the psychological impact on human populations cannot be ignored. The mere idea of black holes as portals could lead to increased fear or fascination with the unknown, which might drive conservation efforts for certain species or habitats, depending on how people perceive these. The concept of black hole portals is a fascinating area of theoretical physics that could significantly change our understanding of the universe and events like the Big Bang. Imagine a black hole not just as a region in space where gravity is so strong that nothing can escape, but as a potential gateway to other dimensions or even different points in time. Some scientists propose that these black holes might be linked to the very fabric of the universe, creating tunnels or wormholes that could connect distant parts of space and time. If this is true, it means that black holes could serve as portals to alternate realities or even to the moment of the Big Bang itself. This idea suggests that rather than being the end of something, black holes could be the beginning of new cosmic phenomena, allowing matter and energy to escape into other universes or times. Such a theory would redefine our understanding of cosmic events, indicating that the Big Bang might not have been a singular event but rather part of an ongoing cycle of creation and destruction, where black holes act as the catalyst for new universes. Furthermore, if black holes can indeed act as portals, they may preserve information about the matter that falls into them, leading to the intriguing possibility that we could one day decode the secrets of the universe from these enigmatic structures. This notion challenges the traditional view of black holes as mere cosmic vacuum cleaners, instead presenting them as vital players in the grand narrative of the universe's evolution. The implications are profound, as they suggest that everything we know about the cosmos could be just a chapter in a much larger story, one that spans multiple dimensions and realities. In light of these ideas, researchers continue to explore the mathematical frameworks that underpin these theories, utilizing advanced models and simulations to test the viability of black hole portals. With every new discovery, we edge closer to unraveling the mysteries of the universe. The potential to connect the black holes we observe today with the birth of the universe could lead to a deeper understanding of not just how the universe began, but also how it might evolve in the future. As scientists delve deeper into the nature of black holes and their properties, the very essence of time and space may be rewritten, allowing us to ponder questions that were once considered purely speculative. This ongoing exploration keeps the frontier of astrophysics alive, inviting both seasoned researchers and curious minds to contemplate the wonders of the cosmos and the pivotal role that black holes may play in revealing the universe's ultimate truths. While the concept of black holes often feels distant from the realm of wildlife and animals, intriguing parallels can be drawn when we consider the mysteries of the universe and the creatures that inhabit it. Imagine if we could explore the vastness of space with the same curiosity that drives us to understand the behaviors and habitats of animals. Just as scientists conduct experiments to uncover the secrets of black holes, researchers study animal behaviors to understand their roles in ecosystems. For example, scientists might observe how certain species interact with their environment, which can reveal patterns in relationships similar to how physicists look for evidence of gravitational waves near black holes. One fascinating experiment might involve tracking the movement of animals during seasonal migrations, akin to studying gravitational forces that influence celestial bodies. Researchers could use GPS collars on animals like caribou or monarch butterflies to gather data on their routes, behaviors, and the environmental factors that guide them. This data could then be analyzed to reveal patterns, much like astronomers analyze light from distant stars to infer the presence of black holes. Another approach could involve creating simulated environments to observe how animals adapt to changes, similar to how physicists create models to understand black holes' event horizons. For instance, researchers could manipulate the habitat of certain species, introducing variables like temperature or food availability, and then monitor the animals' responses. This experiment could help shed light on adaptability and resilience, echoing the theories about how matter behaves in extreme gravitational fields. Additionally, just as experiments are designed to test hypotheses about black holes, wildlife researchers might devise experiments to test social structures within animal communities. By placing different species in a controlled environment, scientists could observe interactions, dominance hierarchies, and cooperative behaviors. These insights could lead to a greater understanding of how social dynamics in animal groups mimic the complex interactions theorized around black holes, where matter and energy behave in unpredictable ways. Moreover, analyzing vocalizations and communication methods among animals could parallel the search for signals from black holes. Researchers could set up sound recording devices in habitats of social animals like dolphins or elephants to study how they communicate and influence each other's behavior. This could provide insights into social structures and interactions, much like how scientists look for signals from the universe that might indicate the presence of black holes. In the realm of genetics, experiments could explore the adaptability of certain species to changing environments, similar to how physicists study the fundamental properties of matter. By examining the genetic variations in populations of animals facing different ecological pressures, researchers can uncover how species evolve over time. Advanced civilizations, often imagined in science fiction, might explore the fascinating concept of manipulating black holes to create portals for travel across vast distances in space. Black holes, formed from the remnants of massive stars that have collapsed under their own gravity, are regions in space where the gravitational pull is so strong that nothing, not even light, can escape. The idea of using them as portals hinges on the theoretical physics of wormholes, which are shortcuts connecting two separate points in spacetime. If a civilization possessed technology far beyond our current capabilities, they might find ways to stabilize a wormhole created by a black hole, allowing safe passage through it. One theory suggests that they could use advanced energy sources to manipulate the environment around a black hole, creating a stable entry and exit point. This would involve understanding and controlling the intense forces at play, such as gravitational waves and the event horizon, the boundary surrounding a black hole beyond which nothing can escape. Such civilizations might also harness quantum fluctuations, which could help them to stabilize a wormhole's throat, making it possible to traverse between two distant locations in mere moments. Imagine a scenario where a civilization develops a technology that allows them to generate exotic matter, a theoretical substance with negative energy density, necessary for keeping a wormhole open. With this exotic matter, they could create a stable passage through the black hole, effectively transforming it into a cosmic highway. This would require not only incredible advancements in material science, but also a deep understanding of the laws of physics as they relate to spacetime. Furthermore, there might be a way to use the rotational energy of certain types of black holes, known as curved black holes, which spin at incredible speeds. By tapping into this rotational energy, advanced civilizations could potentially manipulate the fabric of spacetime around them, creating a ripple effect that opens a pathway through the black hole. This manipulation could lead to the development of a system where travel to different parts of the universe becomes routine, allowing explorers to visit distant galaxies or even different points in time. While all of this remains theoretical and firmly in the realm of speculation, it serves as a fascinating canvas for scientists and writers alike to explore the potential of advanced civilizations and their relationship with the cosmos. The idea of black holes as portals invites us to ponder not just the limits of our understanding of physics, but also the boundless possibilities that could exist in the universe, igniting our imagination about what life could be like beyond the stars. The concept of using black holes as portals is a fascinating topic that brings together ideas from physics, ethics, and even the realm of science fiction. First, we must consider the nature of black holes themselves. These cosmic entities are regions in space where gravity is so strong that nothing, not even light, can escape. The idea of harnessing such powerful forces for travel raises several ethical questions. For instance, if we were to use a black hole as a portal, we would need to think about the safety of the travelers. What happens if someone gets too close to the event horizon, the point of no return? The potential danger of being pulled into a black hole poses serious risks, and it leads to the question of whether it is right to even attempt such travel when the consequences could be so dire. Furthermore, considering the unknowns of what lies on the other side of a black hole is another ethical dilemma. If a black hole could serve as a gateway to another part of the universe, or even another universe altogether, we would need to think about the implications of our actions. Would we be invading another realm, possibly disrupting ecosystems and life forms that exist there? The ethical considerations extend to the impact on potential extraterrestrial life. If we encounter other beings, what rights do they have, and how should we treat them? The responsibility of human beings as explorers must also be taken into account. Would we act as stewards of new worlds, ensuring that our presence does not harm them, or would we exploit resources without regard for the consequences? In addition to these philosophical questions, we also have to consider the technological and societal implications of using black holes for travel. The pursuit of such advanced technology may lead to inequalities in access. If only a privileged few can utilize these portals, it could create a divide between those who can travel the cosmos and those who cannot. This raises questions about fairness and justice in our society. Moreover, there is the potential for misuse of this technology. If black holes were to become accessible, how could we prevent them from being used for harmful purposes, such as war or exploitation? The ethical responsibilities of scientists and governments in regulating this technology would be paramount. Finally, the notion of time travel, often associated with black holes, adds another layer of ethical concern. If we could travel back in time or to different points in time, the implications could be profound. Would it be ethical to alter past events? What if someone could prevent a tragedy from occurring, but also inadvertently caused a? While black holes are fascinating cosmic phenomena, the concept of portal travel through them brings up a host of challenges, especially when considering the safety of such an endeavor. To safeguard against the potential hazards of portal travel through black holes, scientists and researchers would need to develop a multifaceted approach that combines advanced technology, deep understanding of physics, and rigorous safety protocols. First, it would be crucial to gain a much clearer understanding of the nature of black holes themselves. This includes studying their gravitational pull, event horizons, and the effects of extreme gravity on matter and light. Understanding these factors could help in creating a theoretical framework for safe travel. Moreover, the development of highly sophisticated spacecraft equipped with cutting-edge materials that can withstand immense gravitational forces would be essential. These spacecraft would need to be designed not only for durability, but also for maneuverability in the unpredictable gravitational field surrounding black holes. Additionally, engineers might explore the possibility of using advanced shielding technologies to protect travelers from radiation and other hazardous elements that could be present in the vicinity of a black hole. Another important aspect would involve establishing a strong communication network capable of transmitting data between the spacecraft and mission control. This would ensure that any anomalies during the travel could be monitored and addressed in real time, allowing for quick decision-making if any dangers arise. Furthermore, extensive simulations and training for astronauts would be necessary to prepare them for the unique challenges of portal travel. By running simulations that mimic the conditions near a black hole, astronauts can learn how to react in various scenarios, potentially increasing their chances of survival. In addition to technological advancements, it would also be vital to implement strict ethical guidelines and safety protocols to govern the exploration of black holes. This includes thorough risk assessments and contingency plans to manage unexpected situations. It's important that any travel through black holes is undertaken with an understanding of the potential consequences, both for travelers and the broader universe. Finally, interdisciplinary collaboration among physicists, engineers, and safety experts would be essential to create a comprehensive strategy for safeguarding against the hazards of portal travel through black holes. By pooling knowledge and resources, the scientific community can work together to tackle the immense challenges posed by this extraordinary frontier of space exploration. The balance between excitement and caution will be key in ensuring that humanity's quest to explore these mysterious cosmic gateways is both adventurous and safe. Exploring the concept of black holes as potential portals invites a fascinating intersection of disciplines, blending astrophysics with cutting-edge technology and theoretical physics. To delve into this intriguing idea, several scientific collaborations would be essential. First, astrophysicists would need to work closely with cosmologists to understand the fundamental properties of black holes, including their formation, structure, and the effects of immense gravitational forces. This partnership would help in devising models that could support the hypothesis of black holes acting as gateways to other dimensions or universes. Additionally, theoretical physicists who specialize in quantum mechanics would play a crucial role. Their insights into the behaviors of particles at quantum levels could shed light on how matter and energy might interact at the event horizon of a black hole, potentially leading to a deeper understanding of the fabric of spacetime. These theories would need to be tested through advanced simulations and mathematical models, requiring collaboration with computational scientists who can create and run complex algorithms on supercomputers. Moreover, observational astronomers would be vital in this research, utilizing telescopes and other technologies to gather real-time data about black holes. This data would help scientists identify and analyze the characteristics of black holes in different environments, such as those at the center of galaxies or those formed from the collapse of massive stars. Collaborations with engineers and tech developers would also be necessary to improve imaging techniques, perhaps using radio waves or gravitational wave detectors to capture the phenomena surrounding black holes, offering more insight into their mysterious nature. Furthermore, interdisciplinary collaborations with philosophers and theorists could help explore the implications of these findings. Discussions about the ethical and existential questions raised by the idea of black holes as portals would enrich the scientific dialogue, allowing for a more holistic understanding of the universe. Such collaborations would not only broaden the scope of research but also inspire a public interest in the complexities of black holes and their potential as cosmic gateways, blending science with imagination and curiosity. In this way, the exploration of black holes as portals becomes a rich tapestry woven from various strands of knowledge, each contributing to our understanding of the universe and our place within it. Artificial intelligence, AI, has the potential to revolutionize many fields, including astrophysics, where researchers are exploring the mysteries of black holes and the concept of portals. The vastness of space and the complexity of phenomena like black holes can be daunting, making AI a powerful tool for scientists. For example, AI algorithms can analyze massive amounts of data collected from telescopes and space missions much faster than humans can. This data often includes images and signals that may indicate the presence of black holes or the effects they have on their surroundings. By using machine learning techniques, AI can identify patterns in this data that might go unnoticed, allowing researchers to pinpoint black hole activity or even hypothesize about the existence of portals that connect different regions of space. Moreover, AI can assist in simulations of black hole behavior, helping scientists to visualize how these cosmic giants interact with their environment. These simulations can become incredibly complex, as they must take into account various physical laws and factors. With AI, researchers can create more accurate models and run these simulations at unprecedented speeds. This might lead to new insights into how black holes could theoretically create portals through wormholes, a concept that has fascinated scientists for decades. AI can also help sift through historical data from past observations, revealing new connections and insights that could shed light on how black holes might serve as gateways to other dimensions or regions of the universe. Additionally, AI could streamline the process of peer review and publication in astrophysics, making it easier for scientists to share their findings on black holes and portals with the wider community. By using AI to analyze academic papers, researchers can quickly identify trends and gaps in knowledge, guiding future studies. This could foster collaboration among scientists across the globe, encouraging them to work together on theories about black hole portals. As AI continues to evolve and improve, its role in understanding the mysteries of black holes will likely grow, opening new avenues for exploration in the vast universe. The combination of AI's analytical power and the creative thinking of scientists could lead to breakthroughs that reshape our understanding of space and the potential for interdimensional travel. The concept of black holes has fascinated scientists and the general public alike for decades, sparking numerous theories that explore their mysterious nature. Among these theories, some historical ideas have suggested that black holes might act as portals to other dimensions or even other universes. One of the earliest notions can be traced back to the work of physicist John Archibald Wheeler, who coined the term black hole in the 1960s. Wheeler's contributions laid the groundwork for thinking about these cosmic phenomena not just as dead ends but as gateways to other realms. In the realm of general relativity, Albert Einstein's equations hinted at the possibility of warping space and time, which led scientists to theorize that black holes could connect different points in the universe. This idea gained further traction through the work of physicist Kip Thorne, who explored the theoretical existence of wormholes, tunnels in spacetime that could link distant regions of the cosmos. These wormholes, if stable enough, could act as shortcuts through space, potentially allowing matter or information to travel between black holes and other locations in the universe. Furthermore, some theories in quantum physics suggest that the interior of a black hole might not be the end but rather a transition point. The concept of a white hole, which theoretically could expel matter and energy, has been posited as a counterpart to black holes, hinting at a universe where black holes could lead to new beginnings elsewhere. This idea aligns with the multiverse theory, which suggests that our universe is just one of many, and that black holes could serve as entrances to these alternate realities. In the early 20th century, the idea of portals became more popular in science fiction, but also found resonance in theoretical physics. Authors like Arthur C. Clarke explored these concepts, inspiring scientists to think outside the box. The notion that black holes could allow travel between different times and places captivates imaginations, pushing the boundaries of our understanding. The work of physicists like Roger Penrose introduced the idea of gravitational singularities, where the laws of physics as we know them cease to function. Some interpretations of these singularities suggest they could be linked to other parts of the universe, further fueling the theory that black holes might act as cosmic gateways. This blending of science and imagination continues to inspire research and exploration as scientists use advanced technology to observe and understand these enigmatic objects. Thus, while the existence of black holes as portals remains speculative, the historical theories. Gravitational lensing is a fascinating phenomenon that occurs when a massive object, like a galaxy or a black hole, bends the light coming from objects behind it. This bending happens because of the strong gravitational field of the massive object, which acts like a lens, allowing astronomers to see distant galaxies and stars that would otherwise be hidden from view. By studying how light is distorted around these massive objects, scientists can gain valuable information about their properties, including their mass and distribution. This is particularly intriguing when considering black holes, which are regions in space with gravitational pulls so strong that nothing, not even light, can escape from them. When it comes to black holes, gravitational lensing can provide insights into their connections to other regions of space, possibly even revealing hints about the existence of wormholes or portals. These theoretical structures could connect different parts of the universe or different universes altogether. Some researchers propose that if black holes do serve as portals, the way they interact with light through gravitational lensing might offer clues about their nature. For example, if a black hole were to act as a portal, the light from objects behind it would not only be bent, but might also show unique patterns or anomalies that differ from the typical gravitational lensing effects observed with regular massive objects. This could potentially lead to the discovery of new cosmic phenomena or deepen our understanding of the fabric of space and time. As scientists gather more data from telescopes and space observatories, they can analyze how light behaves around these black holes. The patterns of light distortion might help them formulate theories about what lies beyond the event horizon of a black hole, and whether these mysterious entities could actually be gateways to other dimensions. The relationship between light and gravity in these extreme environments is a key area of research, and gravitational lensing serves as a powerful tool in exploring the unknown, allowing us to peer into the dark, enigmatic corners of our universe. As we continue to observe and measure the effects of gravitational lensing, each new discovery could bring us closer to unraveling the mysteries of black holes and their potential roles as portals, transforming our understanding of the cosmos and possibly reshaping our view of reality itself. The interplay between light and gravity is not just a scientific curiosity, it represents an opportunity to explore fundamental questions about the universe, our place within it, and the hidden connections that might exist between seemingly isolated regions of space. In this ongoing quest for knowledge, every observation made through the lens of gravitational effects brings us one step. When matter enters a black hole portal, it encounters some of the most extreme conditions in the universe. A black hole is formed when a massive star collapses under its own gravity, creating a region in space where the gravitational pull is so strong that nothing can escape from it, not even light. As an object approaches a black hole, it experiences a phenomenon known as spaghettification. This term describes how the immense gravitational forces stretch and compress the object, pulling it into a long, thin shape, much like spaghetti. The closer the object gets to the black hole, the stronger the pull becomes, and eventually, once it crosses the event horizon, the point of no return, there's no turning back. Inside the event horizon, the laws of physics as we know them begin to break down. The matter that has fallen in is thought to be crushed to an incredibly dense state. Some scientists believe that all the information about the matter that fell into the black hole could be preserved in some way, although this idea leads to complex theories about quantum mechanics and the nature of reality. This concept is often referred to as the information paradox, which questions whether information can truly be lost when matter is absorbed by a black hole. Interestingly, black holes can also emit particles through a process proposed by physicist Stephen Hawking, known as Hawking radiation. This radiation occurs when particle-antiparticle pairs form near the event horizon. Sometimes, one of these particles falls into the black hole while the other escapes. The escaping particle can then be detected as radiation emitted from the black hole, suggesting that black holes can slowly lose mass over time, eventually evaporating completely. The fate of matter that enters a black hole remains one of the great mysteries of modern astrophysics. While we cannot see inside a black hole, scientists continue to study their effects on surrounding stars and galaxies, using advanced telescopes and simulations to understand their role in the universe. The exploration of black holes not only challenges our understanding of gravity and space-time, but also opens up questions about the very fabric of reality and our place within it. Black hole portals, often the stuff of science fiction, have intrigued astronomers and physicists alike, leading to fascinating discussions about their potential integration into our current models of astrophysics. These portals, theoretically, could act as shortcuts through space-time, connecting distant regions of the universe in a way that challenges our understanding of gravity and the fabric of reality. To explore how black hole portals might fit into existing astrophysical theories, we first need to consider the nature of black holes themselves. These enigmatic entities form when massive stars collapse under their own gravity, creating regions in space where the gravitational pull is so strong that not even light can escape. This makes them invisible and difficult to study directly, yet their presence can be inferred through their effects on nearby stars and gas. Researchers have proposed that if black holes could serve as portals, they might allow for the possibility of traveling vast distances instantaneously. This concept draws on the idea of wormholes, which are theoretical passages through space-time that could connect different points in the universe. If black hole portals exist, they could provide insights into the dynamics of galaxies and the behavior of matter under extreme conditions. Integrating these ideas into our current models would require a re-examination of general relativity, which currently provides a framework for understanding gravity but does not account for the potential of such portals. One avenue of exploration is the study of Hawking radiation, a phenomenon predicted by Stephen Hawking, which suggests that black holes can emit radiation and lose mass over time. This raises intriguing questions about the life cycle of black holes and whether they could be stable enough to function as portals. If black hole portals could be proven to exist, they might lead to new theories regarding the interconnectedness of galaxies, dark matter, and even the origins of the universe itself. The implications for astrophysics would be profound, requiring scientists to rethink not only the nature of black holes but also fundamental concepts of space and time. The idea of harnessing these portals for exploration could ignite a new era of space travel, allowing humanity to reach distant stars and galaxies in a fraction of the time previously thought possible. Imagine a future where we could study exoplanets or even other civilizations across the universe by simply stepping through a black hole portal. Such advancements would not only expand our understanding of the cosmos, but also inspire a new generation of astronomers and physicists to delve deeper into the mysteries of the universe. As we continue to refine our models of astrophysics, the integration of black hole portals, Hawking radiation, named after the famous physicist Stephen Hawking, plays a fascinating role in our understanding of black holes and the complex nature of our universe. It is a theoretical prediction that suggests black holes are not completely black, but instead emit radiation due to quantum effects near the event horizon. This phenomenon arises from the idea that pairs of virtual particles frequently pop in and out of existence in empty space. When this happens near a black hole, one of the particles may fall into the black hole while the other escapes, creating what we recognize as Hawking radiation. The significance of this radiation extends beyond mere curiosity. It hints at an intriguing connection between black holes and the fundamental laws of physics. For instance, if black holes can emit radiation, they can slowly lose mass over time, leading to the possibility that they might eventually evaporate completely. This presents a fascinating dilemma in theoretical physics regarding the fate of information that falls into a black hole, challenging our understanding of information conservation in quantum mechanics. In the context of black hole portals, which are often depicted in science fiction as gateways to other dimensions or universes, Hawking radiation introduces a layer of complexity. If black holes can emit radiation, some scientists speculate that this could be linked to other theories about the universe's structure. For example, if a black hole can radiate energy, it might be possible that it is also connected to other regions of space-time, potentially allowing for the exchange of information or even travel between different areas of the universe. This idea sparks the imagination as it raises questions about the interconnectedness of the universe and the nature of reality itself. Furthermore, the study of Hawking radiation could lead to deeper insights into the fundamental fabric of the cosmos. It pushes physicists to explore the relationships between gravity, quantum mechanics, and thermodynamics, areas that are not fully understood. As researchers delve deeper into this subject, they hope to uncover new principles that govern the universe, perhaps revealing more about how black holes operate and their role in the cosmic landscape. Hawking radiation also encourages a re-evaluation of what we know about black holes. For many years, they were thought to be perfect traps for matter and energy, with nothing able to escape once it crossed the event horizon. However, the idea that they can emit radiation suggests a more dynamic and complex behavior, inviting further exploration and research into the life cycles of these enigmatic cosmic structures. As we expand our knowledge about black holes and the implications of Hawking, the concept of dark matter and dark energy often feels like a mystery, much like the depths of the oceans or the vastness of space. Imagine the universe as a grand puzzle where most of the pieces are invisible to us. Dark matter, which makes up about 27% of the universe, doesn't emit light or energy that we can detect, yet it has a significant influence on the gravitational forces that shape galaxies. It acts like a hidden scaffolding, holding galaxies together and affecting their motion. Dark energy, on the other hand, is an even more elusive force that accounts for approximately 68% of the universe, driving its accelerated expansion. This mysterious energy pushes galaxies apart, creating a tension in the cosmos that we don't fully understand. Now, let's consider black holes, those enigmatic objects in space where gravity is so strong that nothing, not even light, can escape. Some scientists speculate that black holes could act like portals, potentially leading to other regions of space or even other universes. If we think about dark matter and dark energy in relation to black holes, it becomes fascinating. Black holes are formed when massive stars collapse, creating a point of infinite density known as a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. The idea of black holes as portals often involves the concept of wormholes, which are hypothetical passages through space-time. Some theories suggest that dark matter could play a role in the formation and stability of these wormholes. If dark matter interacts with regular matter differently than we expect, it might help create a stable pathway through which a black hole could connect different points in the universe, or even alternate dimensions. Furthermore, dark energy could influence the properties of these black holes and their potential as portals. If dark energy continues to drive the universe apart, it might create conditions where the space-time fabric is stretched and warped, possibly allowing for the existence of these theoretical connections. Some physicists propose that if we could harness the properties of black holes and understand dark matter and dark energy better, we might one day explore the possibilities of traveling through these cosmic gateways. As we dive deeper into the mysteries of the universe, the relationships between dark matter, dark energy, and black holes continue to intrigue scientists and astronomy enthusiasts alike. The interplay of these forces may hold the key to unlocking some of the most profound questions about the nature of reality, the structure of the cosmos, and even the potential for new horizons. Traveling through a black hole portal is a fascinating concept that has captured the imagination of many, but it comes with a host of complexities that challenge our understanding of physics and the universe. First, it's important to grasp what a black hole is, a region in space where gravity is so strong that nothing, not even light, can escape from it. This immense gravitational pull is caused by a massive amount of matter being compressed into a very small area, often resulting from the collapse of a massive star. When we talk about a black hole portal, we often refer to theoretical passages that might connect different points in space and time, sometimes called wormholes. One major complexity involves the nature of spacetime around a black hole. As you approach the event horizon, which is the point of no return, gravity becomes incredibly intense, and time itself begins to behave strangely. To an outside observer, it appears that time slows down for anything falling into the black hole, while for the traveler, they would experience a different passage of time. This discrepancy raises questions about what happens to information and matter that crosses the event horizon, leading to the information paradox. Additionally, the journey through a black hole portal is thought to be incredibly turbulent. The gravitational forces and tidal effects are so extreme that anything passing through could be stretched and compressed in a process known as spaghettification, which is not only a curious term but a dire fate for any object. This gives rise to the idea that traveling through a black hole may not be safe or even possible. Moreover, if a wormhole were to exist, it would need to be stable enough to allow for safe passage. Current theories suggest that this stability may require exotic matter with negative energy density to keep the tunnel open, which has yet to be discovered. The existence of such matter raises more questions about the fundamental nature of the universe. Then there's the question of destination. If one were to somehow traverse a black hole portal, where would they end up? Theoretically, it could lead to another location in our universe or even to a completely different universe, but the unpredictability of such travel adds another layer of complexity. Lastly, let's not forget the sheer scale of cosmic distances. Even if one could navigate the challenges of a black hole portal, the distances involved in space travel are colossal. The time it would take to traverse these distances, even through a theoretical shortcut, could still be unimaginable. In summary, the complexities. When we think about black holes, we often picture swirling masses of darkness in space, but they also spark our imaginations about the possibilities of other universes or dimensions. A black hole is formed when a massive star collapses under its own gravity, creating a point of no return known as the event horizon. Once anything crosses this boundary, it is pulled irretrievably into the black hole. However, some theories suggest that what happens inside a black hole could lead to fascinating possibilities. One idea is that black holes might act as portals, connecting our universe to other dimensions. This concept comes from the idea of wormholes, which are theoretical passages through space-time that could create shortcuts between different points in the universe or even different universes altogether. If a black hole is connected to a wormhole, it could serve as an entrance to another realm, making it possible for matter and information to travel to entirely different dimensions. This leads to the exciting thought that black holes might not just be destructive forces but also gateways to new worlds. Some scientists propose that if you could survive the extreme gravitational forces, which is highly unlikely, you might emerge in another universe. Imagine a place where the laws of physics are different, where time flows slower or faster, or where entire new forms of life exist. While this is purely theoretical, it captures the imagination and encourages us to ponder the mysteries of the universe. In addition, the study of black holes pushes our understanding of physics to its limits. Theories such as string theory suggest there are multiple dimensions beyond our familiar three-dimensional space. In this framework, black holes could be linked to these extra dimensions, potentially offering a way to travel across them. Scientists continue to explore these ideas using advanced technology, such as powerful telescopes and particle accelerators, to gather data and test theories. The more we learn about black holes, the more we find ourselves at the intersection of science and the unknown, where the boundaries of our universe blur and the possibility of other realities beckons. So, while black holes are often seen as cosmic vacuum cleaners, their potential to connect us to other universes or dimensions adds an exciting layer to our understanding of the cosmos, reminding us that the universe is full of surprises waiting to be discovered. Imagine an astronaut floating in the vastness of space, surrounded by shimmering stars and swirling galaxies. The astronaut is on a mission to explore one of the universe's most mysterious phenomena, a black hole. As they approach the event horizon, the boundary beyond which nothing can escape the black hole's gravitational pull, the astronaut feels a mix of excitement and trepidation. The ship's instruments begin to go haywire, with readings fluctuating wildly, indicating the intense gravitational forces at play. As the astronaut crosses the event horizon, time itself begins to behave strangely. To an outside observer, it would appear that the astronaut is frozen in time, slowly fading away as they approach the black hole's center. However, from the astronaut's perspective, they experience its real journey into a realm where the laws of physics as we know them start to break down. The colors of the universe might shift and bend around them, creating a kaleidoscope of light as they fall deeper into the black hole. The immense gravitational pull stretches their body in a process called spaghettification, where the difference in gravitational force between their head and feet becomes extreme. This stretching sensation, although hypothetical, paints a vivid picture of how the astronaut might feel as they are pulled into the abyss, their body elongated like a piece of spaghetti. The astronaut might also witness a phenomenon called gravitational lensing, where the light from stars behind the black hole bends around it, creating a mesmerizing visual effect. As they continue to fall, thoughts race through their mind. What lies at the center of the black hole? Is it a singularity, a point of infinite density, or could it be a gateway to another universe? Scientists have speculated about these possibilities, but there is still no conclusive evidence to answer those questions. They might also wonder about the fate of their ship and whether their data will ever make it back to Earth. The uncertainty adds to the thrill experience. The moment of crossing the event horizon could feel like stepping through a portal, a transition from one reality to another. The astronaut may feel a sense of profound isolation, as no signals can escape from this point, leaving them cut off from communication with the outside world. It's a journey into the unknown, where the rules of time and space twist into something completely unfamiliar. In this strange new environment, the experience would be both terrifying and awe-inspiring. The astronaut might witness the last glimpses of the universe as they knew it, stars becoming. Imagine a world where future generations come to understand black holes not just as mysterious cosmic objects, but as portals to other dimensions or even other universes. In this scenario, black holes would be seen as gateways, much like the doors to a vast and unseen universe, sparking the imagination of scientists and dreamers alike. Children might grow up hearing stories about brave astronauts who ventured into these swirling maelstroms of gravity, encountering strange new worlds and civilizations on the other side. The concept of a black hole as a portal could lead to a revolution in our understanding of physics, prompting new theories that challenge the boundaries of time and space. This shift in perception might inspire a new generation of explorers, eager to unlock the secrets of the universe. Just as we now look to the sky with telescopes, future thinkers might develop advanced technologies to harness the power of black holes, creating devices that allow safe passage through these enigmatic phenomena. Schools could teach about these cosmic gateways, blending science with creativity, encouraging young minds to imagine what lies beyond our current realm of understanding. With every discovery, the allure of black holes could grow, leading to artistic expressions in literature and film, where they are depicted as portals to fantastical worlds filled with alien life and surreal landscapes. This idea might also inspire philosophical discussions about existence and the nature of reality, prompting people to ponder the implications of infinite possibilities. As humanity continues to explore the universe, the idea of black holes as portals may foster a sense of unity and adventure, driving people to collaborate on interstellar projects that aim to reach these cosmic wonders. The narrative surrounding black holes could shift from fear and misunderstanding to fascination and hope, encouraging a deeper connection to the cosmos. Future generations might come to see themselves as part of a larger tapestry, where black holes serve as the threads that connect different realms of existence, igniting a passion for exploration and discovery that transcends the boundaries of our own planet. The idea of black holes functioning as portals is an intriguing concept that has fascinated both scientists and science fiction enthusiasts alike. At the heart of this idea lie several mathematical models rooted in the field of general relativity, which describes how gravity operates in the universe. One of the primary models that support this notion is the Einstein-Rosen bridge, often referred to as a wormhole. This theoretical structure proposes that a black hole could connect two separate points in space-time, creating a shortcut between them. This means that if you were to somehow enter a black hole, you might emerge in another location, or even another time across the universe. Another significant model is the concept of a traversable wormhole, which was developed by physicists Kip Thorne and Michael Morris. They described conditions under which a wormhole could be stable enough to allow for safe passage. This model introduces the idea of exotic matter, which possesses negative energy density and is necessary to keep the throat of the wormhole open, preventing it from collapsing under gravitational forces. While exotic matter has yet to be discovered, the mathematical framework suggests that, in theory, it could allow for the safe traversal of a wormhole. Additionally, the equations of quantum gravity and string theory also hint at the possibility of black holes acting as portals. These theories attempt to unify general relativity with quantum mechanics, and they suggest that the fabric of spacetime could behave differently at extreme scales. In such models, black holes might not only serve as points of no return, but could also function as gateways to other dimensions or even other universes. This opens up exciting possibilities about the nature of reality and the universe we inhabit. It's important to note that while these mathematical models are compelling, they remain speculative. No experimental evidence currently supports the existence of traversable wormholes, and the extreme conditions near a black hole make them difficult to study directly. However, the mathematics behind these theories continues to inspire researchers and thinkers, propelling our understanding of the universe forward. As our technology and observational capabilities improve, we may one day uncover more about the mysterious nature of black holes and their potential as portals. The concept of black hole portals, while still theoretical, could revolutionize our understanding of cosmology in profound ways. If we consider the idea that black holes might serve as gateways to different parts of the universe, or even different universes, our approach to studying the cosmos would shift dramatically. Traditionally, cosmology has relied on observations of light from distant stars and galaxies to build models of the universe, but if black holes can connect to other regions or dimensions, we might need to develop new methods of observation and experimentation. This could lead to the exploration of regions of space that are currently beyond our reach, allowing us to gather information that is not accessible through conventional means. Imagine if we could send probes into a black hole's event horizon, equipped with technology that could survive the extreme conditions. These probes could potentially gather data from other dimensions or regions of space and time, offering insights that challenge our existing theories. Furthermore, the study of black hole portals could lead to breakthroughs in our understanding of fundamental physics, as we would need to reconcile the behavior of matter and energy in these extreme environments with what we know from quantum mechanics and general relativity. As we explore this idea further, we would also need to consider the implications for the nature of time and space. If black holes serve as portals, then our understanding of how time operates across the universe could change. Time may not be a linear experience as we perceive it. Instead, it could be a more complex tapestry influenced by the gravitational effects of black holes. This would require a reassessment of how we think about the universe's history and its ultimate fate. In addition, the idea of traversable wormholes, which are often associated with black holes, suggests that there could be shortcuts through spacetime. This could lead to unprecedented opportunities for travel, not just within our galaxy, but potentially to entirely different galaxies or even universes. Such possibilities would ignite the imagination of scientists and researchers, prompting new questions about the structure of the cosmos. Moreover, if black hole portals are real, it could have philosophical implications, challenging our understanding of existence and reality itself. It might lead us to reconsider questions about life beyond Earth and the possibility of encountering other forms of life in these uncharted realms. The search for extraterrestrial intelligence could take on new dimensions if we believe that black holes connect us to different parts of the universe, making us rethink what it means to be part of a cosmic community. Finally, the very nature of scientific inquiry might evolve as we. The study of black holes has fascinated scientists for decades, and the idea that they could act as portals to other dimensions or universes is a captivating concept that pushes the boundaries of our understanding of physics. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape from them. This incredible property makes them unique cosmic objects, and they challenge our current understanding of the laws of physics. When researchers explore the mathematical framework surrounding black holes, they often encounter theories that suggest these mysterious entities could potentially connect our universe to others, creating pathways through which information or matter could travel. This notion of black holes as portals leads to exciting possibilities. For instance, it could explain phenomena like the behavior of particles at the quantum level or the nature of dark matter and energy. As scientists delve deeper into the properties of black holes, they also study the event horizon, which is the boundary surrounding a black hole beyond which nothing can return. Understanding how information behaves at the event horizon could unlock secrets about the fundamental nature of reality itself. These studies could also lead to new insights into the Big Bang and the overall structure of the universe, suggesting that black holes might play a role in the birth of new universes. Theoretical physicists are intrigued by the implications of these ideas, as they could lead to breakthroughs in our understanding of gravity, quantum mechanics, and the unification of the forces of nature. Moreover, investigating the behavior of matter and energy near black holes could lead to new technologies and innovative ideas in fields such as materials science and energy production. For example, the extreme conditions near a black hole might inspire new approaches to harnessing energy or developing materials that can withstand unprecedented stress. The study of black holes as portals not only enriches our knowledge of the cosmos, but also encourages interdisciplinary collaboration among physicists, mathematicians, and engineers, fostering a spirit of exploration that could yield unexpected discoveries. Additionally, this research fuels the imagination and curiosity of the public, inspiring a new generation of scientists and thinkers to explore the universe's mysteries. With advanced technologies like gravitational wave detectors and space telescopes, we are now able to observe the effects of black holes more closely than ever before. As we continue to push the frontiers of knowledge, the study of black holes may lead us to profound discoveries that reshape our understanding of the universe and our place within it. Each new finding could offer a glimpse into the workings of the cosmos and challenge us to rethink the very fabric of reality, opening Supermassive black holes, those gigantic gravitational entities found at the centers of galaxies, have long captured the imagination of scientists and the public alike, especially in the context of portal travel. While the idea of traveling through portals is often seen in science fiction, some theories in astrophysics suggest that black holes could play a crucial role in this concept. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. This unique property leads scientists to explore the possibility that they might connect different points in space and time, acting like cosmic shortcuts. The notion of a portal implies a passageway between two distant locations, and black holes, with their intense gravitational fields, could theoretically create such passages. One of the more popular theories is the idea of a wormhole, which is a hypothetical tunnel-like structure that connects two separate points in space-time. If a wormhole exists, it could allow for instantaneous travel between the ends of the tunnel. Some scientists speculate that supermassive black holes might serve as gateways to these wormholes, although this remains purely theoretical and highly speculative. Moreover, the environment around a supermassive black hole is incredibly fascinating. The accretion disk, which is the swirling mass of gas and dust that orbits the black hole, heats up to extreme temperatures, emitting powerful radiation. This energy could, in theory, be harnessed or manipulated in some way to create the conditions necessary for portal travel. However, the incredible forces at play mean that any such travel would be incredibly dangerous and currently beyond our technological capabilities. Additionally, there are discussions about how information behaves in the fabric of spacetime around black holes. The famous information paradox raises questions about whether information that falls into a black hole is lost forever or if it could be recovered through some form of portal-like mechanism. This idea pushes the boundaries of our understanding of physics and challenges our concepts of reality, suggesting that the universe might be more interconnected than we can currently comprehend. As we continue to explore the universe, the mystery surrounding supermassive black holes and their potential connections to portal travel inspire both scientific inquiry and imaginative storytelling. Whether they serve as gateways to other dimensions or simply remain the enigmatic giants of our cosmos, supermassive black holes remind us of the vast possibilities that lie beyond our current understanding. Black holes have fascinated scientists and the public alike, not just for their mysterious nature but also for the implications they hold regarding the fabric of space and time. These cosmic phenomena are regions in space where gravity is so strong that nothing, not even light, can escape their pull. When we think about black holes, we often picture a swirling mass of darkness, but they also prompt us to consider deeper questions about the universe, including the concept of infinity. The idea of infinity suggests something that goes on forever, with no limits or end. However, black holes challenge this notion in intriguing ways. When matter gets pulled into a black hole, it seems to disappear from our observable universe, leading to the idea that it may be trapped in a singularity, a point of infinite density. This raises the question of what happens to that matter. Some scientists theorize that black holes could act as portals to other dimensions or even other parts of the universe, suggesting that while it might seem like matter is lost, it could actually be transformed or relocated. This concept introduces a mind-boggling possibility. If black holes can connect to other regions of space or time, then the flow of information and matter may not be as straightforward as we once thought. Moreover, the idea of black hole portals aligns with certain interpretations of quantum mechanics, particularly the idea that the universe is interconnected in ways we are still trying to understand. It is as if black holes could serve as gateways, leading to alternate realities or different states of existence. In this sense, infinity is not just a single endless entity, but rather a complex web of connections and possibilities that could stretch beyond our current comprehension. This interplay between black holes and the concept of infinity stirs the imagination, encouraging us to think beyond the traditional limits of space and time. It invites questions about what lies beyond the event horizon of a black hole, as well as the nature of reality itself. The mystery of whether black holes create new universes or simply recycle the matter they consume adds another layer to our understanding of infinity, suggesting that what we consider the end may, in fact, be a beginning of sorts. In exploring these ideas, researchers continue to push the boundaries of our knowledge, delving into theories that challenge our understanding of the universe. As we learn more about these enigmatic structures, we may find that our definitions of infinity are not as rigid as we once believed. Instead, they could be as fluid and dynamic as the cosmos itself, forever. Imagining a map of the universe where black holes function as portals opens up a fascinating realm of possibilities. In this scenario, each black hole would serve as a gateway to different points in space and time, completely altering our understanding of the cosmos. Picture a vast expanse of stars, galaxies, and cosmic dust, with swirling black holes scattered throughout like mysterious whirlpools. These dark regions would not just be voids, but vibrant entry points, leading to alternate dimensions or far-off galaxies, each with its own unique environment and collection of celestial bodies. As we explore this conceptual map, we could envision a black hole situated within the Milky Way, acting as a shortcut to another galaxy, perhaps the Andromeda Galaxy, allowing explorers to travel vast distances in the blink of an eye. This would mean that instead of spending millions of years traveling at the speed of light, a journey through a black hole could lead to an entirely new cosmic neighborhood. Imagine the wonders that could lie beyond these portals, planets with exotic ecosystems where life thrives in ways we cannot even begin to imagine, or vast star systems with newly formed planets that could host entirely different forms of life. If we were to chart these black holes as portals, we might see clusters of them, forming routes similar to highways, connecting various points in the universe. Each route could represent not just a physical journey, but also an opportunity for diverse encounters with alien species or the chance to witness cosmic phenomena, such as supernova explosions or the birth of new stars. This interconnected web of black holes would challenge our current understanding of time and space, suggesting that perhaps the universe is more accessible than we think. In this imagined universe, navigating through these portals could introduce new challenges and experiences. For instance, stepping into a black hole might mean facing time dilation, where time moves differently depending on one's position relative to the hole. Travelers could find themselves arriving in a different era or witnessing the evolution of a planet over millennia in mere moments. The thrill of discovery would be immense, as each portal might lead to a previously uncharted territory, bursting with new forms of wildlife and ecosystems waiting to be explored. Furthermore, if black holes were portals, scientists and explorers would likely develop sophisticated technology to safely traverse these gateways. Devices might be created to measure gravitational waves or to stabilize the journey through these intense gravitational fields. This could lead to new fields of study in physics and biology, as researchers seek to understand the effects of traveling through such extreme environments. Black holes, with their mysterious nature and powerful gravitational forces, have long fascinated both scientists and the public alike. While they are primarily known for their ability to warp space and time, the theoretical concepts surrounding black holes could lead to innovative advancements in propulsion technologies. Imagine harnessing the energy and unique properties of these cosmic giants. The idea of using black hole portals or wormholes as a means of transportation sparks the imagination, suggesting that we might one day travel vast distances in space much more quickly than we currently can. In theory, a black hole could create a shortcut through space-time, allowing a spacecraft to enter a black hole and emerge from another point in the universe. This concept challenges our understanding of physics and propulsion, prompting scientists to think outside the box about how we might travel in space. By studying the extreme conditions near black holes, researchers could gain insights into high-energy physics and gravitational forces. These insights might inspire new materials or technologies that can withstand enormous stress or harness energy in novel ways. Furthermore, the intense gravitational fields of black holes could inspire propulsion methods that utilize gravitational assists or manipulation of space-time. For instance, if we could understand how to create a stable wormhole, it could lead to the development of propulsion systems that can navigate through these portals, drastically reducing travel time between distant galaxies. The study of black holes might also lead to advancements in fusion propulsion, where the immense gravitational forces are mimicked to create powerful thrust. Additionally, the principles of black hole thermodynamics, which relate to how energy is emitted and absorbed near these cosmic entities, could inform new energy generation methods. By exploring how black holes interact with their surroundings, scientists might develop propulsion technologies that are more efficient and sustainable, perhaps even utilizing the energy of the vacuum of space. This exploration not only pushes the boundaries of our understanding of the universe, but it also inspires engineers and scientists to think creatively about how we might one day explore the stars. The journey into understanding black holes and their potential applications in propulsion could reveal new pathways for human exploration, allowing us to dream of a future where interstellar travel is within our grasp. The concept of black holes as portals is a fascinating area of theoretical physics that has captured the imagination of many, and if proven true, the long-term implications for humanity could be profound. If black holes are indeed portals to other regions of space or even different dimensions, it could revolutionize our understanding of the universe and our place within it. Imagine a future where humanity has the technology to safely enter these portals, potentially allowing us to travel vast distances in the blink of an eye, bridging gaps between galaxies and exploring the mysteries of the cosmos that remain beyond our reach today. This could lead to a new era of exploration, not unlike the age of discovery on Earth, where explorers set sail to uncover new lands. With the ability to traverse through black holes, humanity might encounter entirely new civilizations, ecosystems, and perhaps even forms of life that we have never imagined. The knowledge gained from such discoveries could enrich our understanding of biology, chemistry, and physics, encouraging new scientific advancements and innovations. However, the implications are not just about exploration and knowledge. If black holes serve as gateways to other realities, there could be ethical dilemmas regarding how we interact with those new worlds. Questions about colonization, resource extraction, and the impact on potential alien life forms would demand careful consideration. The responsibility of humanity to act as stewards of these new environments could shape our moral and ethical frameworks for generations to come. Moreover, the existence of black holes as portals might challenge our current understanding of time and space. If traveling through a black hole allows for movement not only across distances but also through time, we could face significant philosophical and scientific questions about causality, destiny, and the nature of reality itself. This could lead to a paradigm shift in our understanding of the universe and our existence within it, prompting humanity to rethink concepts such as free will and the linear progression of time. As we consider the long-term implications, we must also think about the potential risks. The unpredictable nature of black holes raises concerns about the safety of such travel. If humanity were to encounter dangers beyond our comprehension, it could pose existential threats. Additionally, the technology required to navigate these portals safely would need to be developed conscientiously, ensuring that we do not inadvertently create new hazards for ourselves or others in the cosmos. In summary, the idea that black holes could be portals opens up a multitude of possibilities for humanity, from groundbreaking scientific discoveries and ethical considerations to challenges in technology and safety. The future could hold incredible opportunities for exploration, understanding. The concept of black hole portals introduces a fascinating twist to our understanding of the multiverse, which is already a complex and intriguing idea. Imagine black holes not just as cosmic vacuum cleaners that swallow everything around them, but as potential gateways to other universes. If black holes could indeed act as portals, it would suggest that our universe is not the only one. Instead, there could be countless other universes, each with its own unique laws of physics and different forms of life. This could mean that every time matter crosses the event horizon of a black hole, it might not just be disappearing but could be entering a different realm entirely. Such a revelation would challenge our current understanding of space and time, reshaping the very fabric of reality as we know it. If black holes are gateways, then the idea of time would also need to be reconsidered. In these alternate universes, time could flow differently. For instance, one universe might experience time at a slower rate compared to another, leading to the possibility that civilizations could evolve under different timelines, impacting their development and interactions. Furthermore, if black hole portals connect different universes, this could imply that information and energy could be exchanged between them. This idea leads to the question of what happens to the information that falls into a black hole. If it can be transmitted to another universe, could it mean that life forms in those universes have access to knowledge from our own? Or might there be consequences for our universe if others were able to reach out to us through these portals? the existence of black hole portals could also influence theories about the beginning of the universe. Instead of a single Big Bang, there could be multiple events happening across different universes, each giving birth to its own reality. This could lead to a richer tapestry of existence, where each universe contributes to a larger multiverse narrative. Additionally, the very nature of physics might be altered by the existence of these portals. The fundamental forces we know, gravity, electromagnetism, and the nuclear forces, might behave differently in other universes connected by black holes. This could open up a new realm of scientific exploration, as researchers would need to adapt their models and theories to accommodate the diverse phenomena occurring in these alternate realities. In this way, the existence of black hole portals would not only expand our scientific horizons, but also deepen our philosophical inquiries about existence, reality, and the interconnectedness of all things. The implications stretch far beyond mere speculation, providing a Black holes have long captured the imagination of scientists and the public alike, and while they are often thought of as cosmic vacuum cleaners, recent theories suggest they could also serve as portals to other parts of the universe, or even different universes altogether. The idea stems from the unique properties of black holes, which are regions in space where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull results from the collapse of massive stars at the end of their life cycles, creating a singularity, an infinitely dense point at the center. Surrounding this singularity is the event horizon, which marks the boundary beyond which no information can escape. The concept of black holes as portals is rooted in the theories of general relativity and quantum mechanics. Some scientists propose that if you could somehow survive the intense conditions near a black hole, you might find yourself entering a wormhole, a theoretical passage through space-time that could connect distant parts of the universe. These wormholes, if they exist, could allow for instantaneous travel between 2 points in space, making them an intriguing subject of study for physicists. However, the idea remains speculative, as no one has yet observed a wormhole, nor is there a known method for traversing one safely. Moreover, the study of black holes has revealed intriguing phenomena like Hawking radiation, theorized by physicist Stephen Hawking, which suggests that black holes can emit radiation and eventually evaporate over time. This raises questions about the nature of information and matter, as it seems to challenge our understanding of what happens to objects that fall into a black hole. If black holes can disintegrate, what happens to the information contained within them? This paradox has sparked debates among scientists, leading to various theories about the preservation of information and the nature of reality. Additionally, there are ongoing studies about the relationship between black holes and dark matter, another mysterious entity that makes up a significant portion of the universe. While dark matter itself has not been directly observed, its effects can be seen in the way galaxies rotate and how they interact with each other. Some researchers speculate that black holes might play a role in the formation and distribution of dark matter, possibly influencing the structure of the universe on a grand scale. The idea of black holes as portals also finds its way into popular culture, inspiring numerous books, movies, and television shows. These portrayals often mix science with fiction, sparking curiosity and wonder about the mysteries of the universe. They invite audiences